Learn Python from scratch, the easiest way possible. Hi, I'm Vivin Arana, and I would like to welcome you to the world of coding. Story time. Picture this: you have a cool idea for a new app or game, maybe something that recommends outfits based on the weather, or a simple text based adventure where you roam a haunted castle. Now, how do you bring it to life? You tell a computer exactly what to do, step by step, in a language it understands. That language is Python. Python is like learning how to chat with your computer. Instead of random beeps and boops, you'll use words and symbols to get the computer to do awesome stuff for you, whether it's math, playing music, creating a website, or making a game. So let's go ahead and set up our coding space. So first step is to go to python.org and install Python on your machine. To do that, you'll go to python.org, and this is the website for Python where you can learn everything about Python that you can, or you can just follow along with me. And then go to downloads and make sure, depending on what computer you're using, Windows, Linux, Mac OS, or other, install that particular Python version. If you're using Windows, you can go in here and download Python from here. For Linux or Unix machines, you can get it from there. If you're using Mac OS, you can install from there. And by default, it will tell you, it will detect automatically what you are running, and it will ask you to install that version right here. So why are we doing this? You need Python on your computer so it understands the magical code you'll write. Think of it as installing a translator who speaks both computer and English. Now, picking up an editor. Now, to write your code, you'll need one of these editors. The first editor that you can get is Thonny, which is from thonny.org. This is a super beginner friendly. It's like a warm hug that helps you learn. Next, we have the Visual Studio Code or VS Code, which is very popular, powerful, and a lot of pros use it. You might like all the colorful plugins. And finally, we have Google Colab, which we'll be using during our course, so we don't have to install anything on the computer, because a lot of times when you try to install things, they break. So instead of running through those issues, why not just use something on the cloud? So as I mentioned, you can go to thonny.org and install it from here. This is one option that you have. Or you can go to code.visualstudio.com and download Visual Studio for you. Or, as what we are going to do in this course, is go to collab.research.google.com, sign in with your Google account, or if you don't have one, create one, and then start coding from here by saying File, New Notebook in Drive, and it will open a new space or a coding space for you to code. And we will look at it in more detail in the next section. So once you've installed Python and chosen an editor, or you decide to do it, follow along with me and do it on the cloud, you're basically set up your coding studio. This is the place you'll create and test all your masterpieces. Next, let's jump into your first line of code. So what we will be doing here is we'll be writing our first Python script. Now to do that, I'm going to open my browser and go to collab.research.google.com. I'm going to close everything here. I don't need any of these. And I'm going to say File, New, Notebook in Drive. It will create a new notebook. The first thing is always make sure you name your file. So I'm going to say first code.ipynb, which means this is a file called as first code. The name is first code, and it's of the type interactive Python notebook. So that's what we're creating here. So it's kind of, you have a notebook where you keep on writing stuff, writing code snippets, and then come back to it whenever you want. And this is my first code.ipynb. I'm going to go ahead and type my first script. I'm going to call a function. Now, what are functions? Functions is something that we're going to discuss about a little later. But what I'm going to do is I'm going to write a function called as print. Function means a thing to do for the computer. So I am telling Python that, hey Python, print hello world for me. So when I do this, I am telling I'm telling Python that hey, print hello world for me, and Python goes, which is a translator, goes to the computer and says programmer wants us to type hello world and display it to the user opening it. I'm going to go ahead and press this play button right next to it, or it will says here control enter is another option. It takes a little bit of time first time, so have some patience, but going forward it will be much more faster. So we'll run through that code and it will print me hello world. If I say hello Vivian and then run it, it will change that and says hello Vivian. And if you noticed, you see how fast it is. Now usually if you're creating a file, you would probably create as this as hello.py, which is a Python file on your computer, and save it and run it from your command prompt or your terminal, depending on which machine you're using. But if you're using cloud, you can directly run it from your browser itself. So congratulations, you just told the computer to display a greeting. It's a small step, but every coding journey starts with hello world. Next, let's jump into variables, your virtual boxes. Imagine your room filled with boxes, each labeled with a name. There's a phone charger box, there's a snacks box, there's a guitar picks box. In coding, variables are like these boxes. You label them and put stuff inside them. So let's go ahead and see some examples. I'm going to go here and I'm going to say I want to write another code snippet and click on code. And then here I'm going to create a variable name. Name is the name of my variable. And I'm going to say name is Vivian. It helps me type this without doing anything. This is a string text, which means it's characters inside double quotes. So it's a string. So that's a string text, which means this name variable is saving a string variable, and the value of that string variable is Vivian. You can change this to whatever you want. You put it your name or put hello world in there, but that's what a string variable looks like. This is a string variable. So think of it as a box which has strings inside it, which has characters inside it. Next, I'm going to create an integer, which are whole numbers. I'm going to say age. Now, age is a variable which has integers inside it. I'm going to say 15 here. So this again, this is a box which is named as age, and it contains whole numbers inside it, which is also called as integer in programming languages. Next, I'm going to create something called as height. Now, what happens if it's not a whole number? For example, my height is, let's say, 5'8". So I say 5.8. Now, this is called as a decimal number or a float number. So this in programming languages is called as a float. So the box, which is called as height, has a float value inside it, and that value is 5.8. Now, there's also something called as a boolean, which is true or false. So I'm going to say, is this person a gamer? I created a box which is called which tells me if this person is a gamer or not, and I can set it to true or false. Now this is a boolean, which means the value of this can be true or false. If I'm not a gamer, I'll say false. If I'm a gamer, say true. So boolean can have only two values, true or false. Height, as I mentioned, this is a float or a decimal number, so it can have a lot of numbers inside it. Age is whole numbers, so these are integers. So 1, 2, 3, 4, that's what this contains. And name is a string which you can tell by double quotes. If I remove this, what it means is I'm trying to assign another variable to it, which is not true. So I'm going to give quotes here at the end of it, which means this is the string variable. So we have a string variable, we have an integer variable, we have a float variable, and we have a boolean variable here. Now, if I want to display these out, I can just say print, and I am not going to directly print it. If I directly want to print it, as the computer is telling me, I can do this. I can say print, I can print name, I can print age, oops, I can go ahead and print height, I can go ahead and print is gamer. Now, if I try to print this, let's go ahead and press play here. It will execute this and it will go through this. It will create a box called as name. So what Python is telling the computer is create a box, name it name, and assign the value Vivian inside it. Age, assign the value 15. And so computer is creating in its hard disk this particular data and saves it there. And then when I say print, it will go to that box, find what the name is, and display it outside for me. So this is how this works. Now, next option is how do I make it look more pretty? So I can also say that I want to print name, and I can just say comma. So what this will do is it will say name of this person is Vivian. So it kind of gives a nice label. So similarly, age, I can say comma, this is the age of Vivian. This is height of Vivian. Let me just make sure I put colons everywhere, and make sure you have your commas in place or it will not work. And I'm gonna say is gamer. I'm gonna put a question mark here, and then that will tell me whether it's true or false. I'm gonna go ahead and execute it again. And you see name is Vivian, age is 15, height is 5.8, and is gamer is true in this particular case. So now what we are doing is you can open the box called name here anytime to see what the stored value is. In this particular case, we have name as Vivian. I can create another code piece here. And if I print name here, again, it will still work and it'll save it into that box. So every time I want to remove it, I can remove it and check it out. So that covers our variables. Let's go to our next section, which is talking to the user or taking an input from the user from the coding interface. It's like when you log into your gaming console, and you say that, oh, I want to play a game, and you'll ask, what is your name? And you enter a name inside there. So we're going to do something like that. So I'll go back to my browser, and here in my new coding parameter, if you don't have this, just press this code button and a new snippet will be available for you to type here. I'm going to say user underscore name. So I want to know what the user's name is. So I'm going to creating a variable called as username. And then I take input from user. So I'm going to say input, and I'm going to ask the user, what's your name? Question mark. So what this does is it calls this input function, just like our print function. It will call this input function and it will print this out to me and expect an answer from the user. So if I just run this here, you'll see it says, what's your name? And it's asking me input, and I can say Vivian Arana, enter. And then username value is Vivian Arana. Now I can do a little bit more, is I can say print welcome, comma, and then I'll say username. Now when I run this, I'll play it. It says, what's your name? And I say Vivian, enter. It says welcome Vivian. So it will go through this line and wait for the user to enter the value before running into the next file. So what we're doing here is we are doing some hardcore coding. Now coding is a conversation with your computer, but what if you want a conversation with the person using your program? That's where input comes in. Now when we run this, as you saw, your program will stop and wait until the user types something. Then it prints a greeting to your user. And if you want to make it more prettier, you can go here and say plus. So what you're doing is you're adding values, but this username is a variable and the rest of the items that I have is more of a string. So I have to put everything under string, and I'm going to say add this whatever the variable is in here. If I remove this here and just type it something like this, it will just type welcome comma plus username value, but I don't want that. I want whatever user entered the variable, I want to get that. So print command looks at what did you enter, and if there's any variables in there, it will take that variable and add it depending on how you display it out there. And now when I play it, it's going to ask me again, what's your name? And I'm going to say Vivian, enter. It says welcome comma Vivian this. And if you want to format it nicely, you can always do that and enter any random value, and it says welcome comma random, and you can play around with it. I hope you were able to get it. If you had any questions or had any issues here, let me know in the messages. Now to move on to our next step, we're going to do some math magic. Now who needs a calculator when you have Python? Let's do some quick math. So I'll go ahead here, create a new code snippet, and here I'm going to create a variable first, x equal to 3. Next, I'm going to create another variable y equal to 10. Now, what type of variables these are? Now, based on what you learned earlier, these are integer types of variables. Now, if I want to do some math here, I can just type print x plus y. What this does is it takes the first integer and adds it with second. Now, similarly, why didn't it add stuff here? Because this is a string. In string, it just concatenates different strings together and makes an entire sentence out of it. But here, since these are numbers, these are integer types, and they are not inside something like quotes. If I put quotes here, it will display to me 310, something like this. But if I remove this, it will take the number 3 and the number 10 and add it like a calculator. Next, I can also do print y minus x. The reason I'm doing y minus x is y is a bigger number. You can do x minus y too, and it will give you a negative numbers. I can do print, what are the other math? X times y. So this will do a multiplication operation. Next, I'm going to want to do a division operation, which is x divided by y. Next, I want to do integer division, which what it does is it will drop the decimal places, because if you look at 3 divided by 10, it should be like 0.333 something. So it will give me 0 in this particular case. So that is done by using double slash. I can, to make it more clear, I can do y divided by x, and same thing here. Oops, y, yeah, there you go. Our next thing that I want to show is a modulus, which kind of gives you the remainder of the operation. So in this particular case, I'm going to say y modulo x. So it will try to see what is the divisor of this, so and give me the remainder of that. So for example, 3 times 3 is 9. How much is left? Remainder 1. And that's what this will show me as an output. Next, I can do print y star star x. This will give me 10 to the power of 3, which is 1000, and that's what will be displayed to me. Let's go ahead and play it. And as you can see, x plus y is 13, y minus 3 is 7, x times y is 30, then 3.333 for y divided by x, and y integer division gives me just 3 and drops all the points. Remainder y mod x modulo operation will give me 1, and my x raised to 3 will give me 1000. So try making a little calculator program for yourself. It's a perfect beginner project. Next, it's decision time. If, else. Now in real life, you make decisions all the time. If it's raining, grab an umbrella. Else, just wear shades. Now Python does the same. So we're going to go ahead and write some decision code. So I'm going to go back to my browser and go ahead and create a new code. And here I will say first age equal to integer of, so I'm going to ask user, what is your age? And for that, I'm going to say input, enter your age. The reason I am saying int in front is because if I just do this, whatever user enters will be taken as string. So if I enter 25, it will just enter my age as 25 as a string. But I want to convert it into an integer. So I can say, I can add int in front of it in brackets, and then whatever input user enters, so if I say 25, it will convert that into a number, an integer number, and assign it to age. So that's why I'm using int here. And now it's decision time. So I'm going to ask a question. If age, I'm asking the computer, if age is greater than equal to 18, I'll say print you are an adult. Or else print you are a minor. So that's an if else statement. So now not both will be ever displayed, because if I enter my age as 18, it will display the first one, you are an adult. If I say 15, it will not print this one because this is false here. If age is greater than equal to 18, if I say 15, it is less. So it will say print, you are a minor. So go ahead and run this. It will ask me, what's your age? And I'm going to say 15. And it goes through this and it looks at this decision here, makes a decision, looks at the value and checks it's 15, which means it should not run this, and it will run else loop here. I'll print this. If I run it again, and this time I'll say my age is 33, enter. You see you are an adult, because it runs through this decision here if age is greater than 18, which is true in this case, and it will print this and it will ignore the else side of it. I can also use else if, where I can say here ELIF, that is else if age is, let's say, greater than 13, you are a teenager, else you are a minor. If it's less than that, then it's a minor. So if I run this here, and now I have three different conditions that I have to looking for. If I am 25, it will say you are an adult in this particular case. If I run it again, and I'll say my age is 15, in this case it will, I just stopped this, let me run it again. If I say 15 and enter, it will check the value here, greater than 18, nope, and then it will check else if age is greater than equal to 13, it is, it's 15, so it say you are a teenager. And one more case, if I say I am 10 years old and run it, it says you are a minor. So that's how if else works. Now next, we are going to look at loops, which are repeating actions. There are two different loops that I want you to look at. First is the while loop, where you want to go over something over and over again until a particular scenario is met. For example, maybe you want to do 10 jumping jacks, so you keep counting until you hit 10. So that's how you write a loop. Now you don't want to write it hard coded into the code where you can say, okay, jumping jack 1, jumping jack 2, 3, 4. Instead of that, you can write a loop. So let's look at how to write a while loop. I'm going to go ahead and open my browser, and here I'm going to create another code piece, and in this particular case I'll say count equal to 0. So I'm creating an integer variable here, and then I'm checking if while count is less than 5, in this particular case I am going to say count is this value, and then I want to reduce the count. Now the one way to do reduce the count is count minus 1. So what I'm doing here is I'm checking, is count less than 5? In this case it's 0, so I am going to say, so I think I have an error here. Instead of reducing, I want to increase it. The reason is I'm checking if the count is less than 5, it is less than 5. I'm going to say print count is, in this particular case it will print as 0, and then it will go ahead and increment the value of count by 1. So whatever the initial value is 0, it will increment by 1, and now the value of count is 1, and it checks again while count is less than 5, 1 is less than 5, so it's going to go ahead and print it again. Again it will go in and increase the value. From now 1 becomes 2. Now this is increment operator, where you can directly say, instead of doing that extra work, you can say plus equal to 1, where it increments. If you want to decrement, you minus equal to 1. So since I want to increment, I'm going to do this, and now when I run through it, what it will do is initially it will print when the value of count is 0, it's a print count is 0, then add 1 to it. Now the value of count is 1. It will check again. I'll say 1, 2, 3, 4. Now when it's printing count is 4 here, it will check count, it will increment by 1. Now value becomes 5. Now is count less than 5? Is it still less than 5? 5 is not less than 5. 5 is equal to 5. So it will come out and close the program. That's what's happening here. Now this code, as you can see, prints the count from 0 to 4 one by one. Now if I want to do it for 10 times, you can save it, run it, it will say 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 until value is met. Similarly, you can do 100, thousands, whatever you feel like, you can add it here. Next, I want to talk about for loop. Now, for loop is used where you have a list of chores and you want to go through them one by one. So you are given a list in this particular case. So for example, you have 10 video games and you want to find the right game to play. So you go through each one of them until you find it. And when you find it, you can stop going through the disk set, or you can just keep on continuing if you want to see if you have 2 of those. So I am going to go ahead, add another code snippet here, and then I'm going to say video underscore games equal to, and I'm going to make a list. Now to make a list, I can use square brackets, and inside that I can say game 1. Next I can say game 2. Next game 3. So let's say I have 3 games here. Now I want to go through each and every game and then print these games that I have. So for that I can say for game in video games, I want to print the game name. So what it does is it will go through each and every one inside here. So first it will go to the first one, it looks at this name and assigns it to this and then prints it out. Then it goes to the next one, does the same thing, assigns it to this variable game and prints it out third. So it will keep on going through that. So if I run this, and as you can see, it prints each and every game out for you. So that's our while loop and for loop. Next, let's look at list, where you keep track of all your stuff, like video games that we just did. Now a list is a playlist on Spotify. It contains a bunch of items in a particular order. So let's say your music orders. Now of course you can shuffle them, but let's say if you want to go through in a particular order, that's what lists are used for. Now let's look at some of the functionalities that lists provide. So we already created a list. Here we have a game list. Now I am going to go ahead and comment this. When I put the hashtag or pound in front of any of my line in code, what Python does is it just ignores that line of code. So if you see here, nothing is happening because it just go through this and then it will ignore this and it will ignore this. So what this pound sign does, it tells the computer, the code is telling the computer, just ignore it, don't do anything with it. So all it does is it creates a list with 3 games inside here. Now if I want to look at my first game, I'm going to say video game of 0. I don't want to see all of them, so I'm going to just say video game of 0. What that will do is that will just print me the item in the first element. Now why didn't I say 1 here? The way lists work is they start with an index 0. So this is 0, this is game 1, and this is game 2. How many items do I have? I have 3 items in here. So length of this list will be 3, but the index or the ranking starts with this is the 0, this is 1, and this is 2. So if I say video games of 0, it will print me the first item in here, which is game 1. Now next, I can add items to this video games list. I can say video games dot append. I want to append a game 4. And now if I want to look at what I have inside this video games variable, it's already was a list of 3 items and I'm saying append add game 4. So I should see the 4th game. I'm going to go ahead and comment this because I don't want to see this line printed. It goes through this and it looks at this and it will print out game 1, game 2, game 3, game 4. I can also change a particular item inside here. I can say video underscore games, and inside the first item for index 1, which is this one, index 1, I want to change that and call it game 8. So think about it, you have a drawer of or a box of items and then you want to remove the second item and replace it with something else. That's what I'm doing here. Now let's go ahead. I'm going to take this code here, put it down here and run. So if you see game 1, game 8, game 3, game 4. What happened to game 2? So what I did by doing this is I took the game 8 and I replaced game 2 with it. I threw away the game 2 and game 8 was added in place of game 2. And that's how you do that in lists. So that takes us to functions. Now we have already called some functions. We've called the print function. We've called the input functions. What functions let you do? Let you build your own commands. So whatever functions we've used till now are the ones that are available by Python, which was print and input. But now imagine you can do a certain task a lot, like sending a greeting message. Instead of copying the same code repeatedly, you define a function once and then call it whenever you want. So for example, let's go back to the code and create a new one. And here I am going to create a function. The way to create a function is you say def. This is how you define a function. and then you give the name of the function, say underscore hello. So that is my function name. And inside here, so if I want to put anything inside a function, I give a colon and then enter next line and make sure this is indented, because whatever is indented is in part of the function. So I can say print hello from your very first function. Okay, so that's there. Now I'm going to get out of the function by going back, and I'll call that function by saying say hello and then brackets next to it. So that's how you create a very simple function, and I can call it like multiple times. It will, let's say, it will keep on printing hello from your very first function, hello from your very first function. Depending on how many times you call it, it will call this function and it does whatever you ask it to do inside the function. So that's how functions work. Now we've seen like print, and then we gave some video games inside here. There's no value here. So these things are called parameters. The variables that you give inside are called parameters. So what I am going to do is I'm going to say that this function takes a parameter called as person name, and then instead of like here, I am going to append to that the person name to it. So it says hello, whatever the name is, hello, let's say I pass Vivian, hello Vivian from your very first function. That's what will be printed. Now this doesn't exist anymore here. Since I say hello and I gave empty brackets here, it doesn't exist anymore because this function takes a parameter. So I can say here hello Vivian, and I'm going to remove everything else. Now what happens here is I say hello, and instead of giving a variable, I gave the value of a variable, which is a string. It will take that string value and assign it to this variable, and then it will say print hello, pass that variable name's value in here. You say hello Vivian in this case from your very first function. I run it. I'll say hello Vivian from your very first function. Now if I want to change this to, let's say, Clyde, and run it, it will say hello Clyde from your very first function. Now depending on what the user says their name is, you can give a personalized message and just call this, and don't have to write this as a part of your code, and you can reuse this as many times as you want. Now another thing that this can do is it can also return, functions can return values back to whoever called it. So for example, I want to create another function which multiplies two numbers. So this takes two numbers. You have to pass two numbers as parameters, and what it will give you back, it will return back. So you have to specifically say a return a times b, and then I'll go to the next line, and here I will say result. I'll create a variable called as result equal to, let's say, multiply 3 comma 5. So what I'm doing here is I'm calling this function multiply, and I'm passing values 3 and 5 to this. So variable a's value will be 3, variable b's value will be 5, and it will return back a times b, 5 times c, 15, back to this result variable, and then I'm printing this out here. I can always say result comma, make it look nice, play. And now if you see here, result is 15. Now I just change the value here. Let's say 15 times 3, run it, and it will say 45. How about 30 times 15? It will just be one more 0, 450. So there you go. So this is how you can pass or call this multiply function again and again, bunch of different times. So this brings us to our next part, which is a mini project, number guessing game. So we will be writing a game using whatever we have learned till now. We'll use random numbers, we'll use loops, we'll use conditionals, we'll use input from the user, you name it, we'll use everything. Again, we've not looked at random numbers, but we will be creating random numbers. So to do that, first, let me go to my browser, and I'm going to create a new code here. And inside this, I'm going to import something called as random. Now this is a library that Python provides us, which has some functionalities or functions that creates random numbers for us. So I am going to say secret number. This is what computer will give me, random dot random integer 1 comma 10. So what this will do is This will create me a random integer number between 1 and 10, and that will be assigned to secret number. Now I don't know it, you don't know it, we don't know what it is. The only person who knows about this secret number is our Python code and the computer which generated it. So I am going to say the user has 3 attempts to solve this. So I'm giving user an opportunity of 3 attempts, which I will reduce every time user guesses the number. Next, I'm going to tell the user print I am thinking of a number, if I can type properly, between 1 and 10. So I'm asking the user, can you guess a number? Now I'm going to check first while attempts is greater than 0. So if the user has still any attempts left, the user has 3 attempts, attempts is greater than 0, I'm going to say guess equal to integer input. Since user has options, I'm going to say take a guess. Another good part about this editor here of Google Colab editor is it completes your code for you. So if you are stuck somewhere, it will help you complete the code for you. So anyways, so now I am taking a user's input here. User will say, let's say 5, that I'm converting into int, and I'm assigning it to value guess. So then I am going to check here if guess is equal to secret number. I'm going to say congratulations, you have guessed the number, or I'll say break. So I'll get out of this loop and I'll say else. If guess is less than, I'm going to say too low, else I'll say too high, and then I am reducing the attempt by one more, -1. Next, I'm going to check how many attempts are left. If attempts, oops, attempts equal to 0, I'm going to say sorry, you run out of attempts. The secret number was whatever the number was. So what I'm doing is I'm telling the user you have 3 attempts and asking the user. So if the attempts is greater than 0, so first time it will be 3 attempts. User will say, let's say the secret number is 5. The user will say, let's say 8, and then I'll check if 8 is equal to 5. It's not. So I'm going to say, wait, your number is too high. The number is 5. So kind of depending on what the user guesses, I will give them a hint saying too low or too high, and then I will reduce the number of attempts. Again, the user will try to guess, and if the user runs off all the attempts, which is 0, then I'll say sorry, you've run out of attempts. The secret number was, I'll give the number. So let's go ahead and play this game, and if let's see if everything works fine. Say play. Think your number between 1 and 10. Take a guess. I'm going to say 5, and it says too low. Try again. So it means it's between 5 and 10. So I'm going to say my second attempt, I'll say 7, and it says too low. Try again. So that means it's between 7 and 10. So I'm going to say 8. Too low. Try again. So I think it was, in this case it was 10 and not 8. So it guessed a number very high. I'm going to run it again. Take a guess. I'll say 5. Too low. I'm going to say 8. Too low. What is again? 10 again. Congratulations, you guessed the number. It guessed 10 twice. Let's try again. Let's see. I'm going to say 5. Too low. Is it 10 again? Too high. Okay, so it's between 5 and 10. I'll say 8. Oh no, it was 9. It's kind of trying to guess pretty high numbers. Let's see if it can guess a low number. 5 too low. Okay, again. 10 too high. 8. No, it was 6. Anyways, enjoy this game. I hope you were able to build this game and play with it. If you had any questions or issues while implementing this, let me know. And now I think you're ready to deep dive into Python programming. Welcome to day 1 of your 100 days of Python challenge. Today we'll start with the basics of Python programming, the print statement. And by the end of the day, you'll build your first project, a welcome message generator. Let's see what you learned today. First, what is a print statement? Next, how to use print with text and numbers, string formatting for dynamic messages, using user input with print, and finally, our day one project, which is welcome message generator. So let's get started with what is a print message. The print statement is Python's most basic way to display output on the screen. Let's look at the syntax. Here, I have created a Google Colab notebook and I've named it day1.ipynb. Now, ipynb stands for Interactive Python Notebook. And here, I'm going to start coding. Now, just to show you the syntax of a print statement, this is how it looks like. You start with print, open brackets, and you display your message here. Something like this. I can run it, and it will take some time, as I mentioned, when you run it first time, but it will run it in a second, and you'll see your message displayed right below here. And there you go, your message here. Now I can give you an example of a sample print statement. With this same syntax, you can probably say hello Python world. No hello world anymore because we already did that last time. But there you go, hello Python world. And this is how you write a simple print statement. This is how your output should look like. Now let's look at next, which is how to use print with text and numbers. Now Python can print both text, which is strings, which we saw already, and numbers. Now if you want to do that, let's look at an example. I'm going to create a new code snippet, and here I am going to say print the number is, and then if I want to give a number, I just say pass the number here, for example 4, something like this. I can also say print, and then I can say 2 plus 2. Now this is a string, but if I want to display the output of that, I'll actually have to do the operation outside, something like this. When I put anything inside quotes, it's string. No matter what it does inside here, what it says, Python prints it as it is. Whereas if it's outside, it will look at this operation, since you're saying I want to add 2 plus 2, and it will output you 4 in this case. So number is 4, which is the first line, and the second one 2 plus 2, it printed this exact thing as it is, and and it calculated this value 2 plus 2 and displayed 4 here. I can always say 3 plus 2. Now in this case 2 plus 2 is equal to 5. No, that's wrong, but still it will print exactly as it sees here and then calculate this value and display it out here. So this is how your output should look like. Next thing that I want to talk about today is string formatting for dynamic messages. Now sometimes you want to insert dynamic values into a message. Python offers something called as f-strings for this, and we'll probably look at this one more time again in future, but let's look at an example of this. Say code, and here I'm going to say name. I'm creating a variable here equal to, I'll say Vivian, and then I'm going to say print hello. Now if you've seen something similar like this before, where it will print hello Vivian exclamation mark, but another way to incorporate inside this is by using this name. Oops, and then I'm going to remove what it says here, and I am going to say welcome to Python programming. Now the problem here is, as it's probably trying to correct me, is it will not work like this. If I run this, it will just print as it is hello name. But with the help of f strings, which is just put a f in front of here, what it does is it does the formatting for you. As you can see, this changed automatically. It expects a variable inside the curly bracket. So every time you give a curly bracket, it will expect a variable in there, and it will add this value inside this variable, since that's the value of the variable, and display hello Vivian, welcome to Python programming. I'll run it again, and there you go. We have formatting here. Now why use f-string? They're really easy to read, as you can see here, and they're great for adding variables to your text in a simple way without adding like all those extra quotes, commas, plus, minuses. So it kind of creates a nice templating engine for you. Now next, let's look at taking user input. Let's make our program more interactive by asking the user for their name in this case. So I'm going to go ahead and I'll create one more just for the sample of it. And I'm going to say name equal to, the way we take user input is using the function called as input. And here I'm going to say, what's your name? That's perfect. And then I'm going to say print hello, depending on what the name is, welcome to Python programming. Now in my code, I never use the same variable twice in a different ways. In this case, it will print this and then it will assign this as the name, but I'm going to say user name, use this here. Now if I just keep this name here, it will still print Vivian. So I want to display whatever user inputs here. So our user will get a prompt asking, hey, what's your name? And then whatever user says, so this input function, as I mentioned, takes user's input as a string, and then f string formats it and displays the input nicely. So let's run it. And there you go, it's asking what's your name, and this time I'll say my name is John. Press enter and it says hello John, welcome to Python programming. I run it again, it says what's your name? Say my name is Alice. I say hello Alice, welcome to Python programming. There you go. Now finally, that brings us to today's project, which is a welcome message generator. You probably got some idea about it, but the goal here is to create a Python program that generates a custom welcome message based on user's input. The requirements here, let me lay it down for you. First, ask the user for their name, which we already learned how to do it. We'll ask for their favorite hobby, and then we'll display a personalized welcome message to the user. So let's go ahead and write this code. I'm going to move everything to the top, create new code snippet, and I am going to say, these are the comments. If you remember, every time you use the pound sign, whatever you write after that, Python will not interpret it and just ignore it. So this is just for me. In future, if I come back to this file, I know what exactly it means. Let's say welcome message generator. Now, as I mentioned, what's our step one? Step one is ask for user details. I'm going to say name, input, what's your name? I'm going to ask that to user. My next question to the user will be more on the side of their hobby. I'm going to say input, and I'll ask, what's your, I'm not going to say hobby, I'll say favorite hobby, something like this. Now next step is to generate, so it's good trying to be smart here because Gemini is added in here. So it's trying to be smart and kind of guess what I'm trying to do, but I am going to say generate a personalized welcome message. So then I will say print. In this case, I can also use special characters like /n, which adds a new line, /t adds a new tab to it, and there's a bunch of different ones of these formatting tools that are available which we can use. But I'm just going to use /n, which will go to a next line after whatever users enter. It cleans everything, and then we'll add some dash 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 and say welcome message. Okay, and then it says hello name. This is exactly what I wanted to do. I can also add something called as emojis in here, so I can say welcome name, and then I just going to say wave sign here, your, and then I don't want this, I'm going to say f welcome to the world of Python programming. Now I don't have to add f here because this is not a f string, there's no formatting required, but I just keep it just in case if I want to change this to a different programming. If I'm teaching Rust tomorrow, let's say, so I'll say welcome to the world of Rust programming, something like that. I'm going to add two more lines just so that I have some placeholders, and I'm going to say it's great to know that you love, and in here I'm going to add hobby based on whatever user entered here, and that will be displayed here. So full stop, and then finally I'll say get ready to build something amazing today, something like this. So I have this entire message generated. and it will be printing one line at a time. So I'm going to go ahead and run it right now. So I'm going to say play. I'm going to go one step at a time. It stopped here. You can see that green sign here saying that this is where the code is stopped. It says, what's your name? I'm going to say my name is Vivin Arana. Say, what's your favorite hobby? And I am going to say photography, even though it's not, but why not? And it says, welcome message. That's what it says here. Hello, Vivin Arana with a wave. Welcome to the world of Python programming. It's great to know that you love photography. Get ready to build something amazing today. And there you go. That's our welcome message generator. Just to break down to the project, what we've done here is we used input function to collect the user's name and hobby. Then we created dynamic message. We used the F string to create a friendly personalized message. And as per formatting goes, we added line breaks and emojis for better readability. Now, if you want to do something more here, a bonus challenge for you for day one is add the current date and time to the welcome message, ask for user's favorite color and include it in the output, and use uppercase or lowercase formatting on the user's input. For example, when users enters their name all small, just change it to uppercase or lowercase depending on how you want to do it. You can use the functions called as upper and lower. So you can just say name dot upper and name dot lower. You can call those functions. Try to have some fun with it and let me know how it goes in the messages. And if you had any problems or have any questions on what we've learned today, let me know in the messages and I'll get back to you. Welcome to day 2 of your 100 Days of Python challenge. Today, we'll explore variables and data types, the building blocks of Python programming. By the end of the day, you'll build a personalized greeting program that asks for user details and generates a fun and dynamic greeting message. Let's look at what you learned today. First, we're going to go over what are variables. Next, we're going to look at different data types like strings, integers, floats, and booleans. Next, we are going to talk about type conversion, then string formatting, and finally, our day 2 project, which is personalized greeting program. So let's look at what are variables. A variable is like a container where you can store data such as names, numbers, or even calculations. Now let's look at how to do variable declaration. First, I've created a Google Colab notebook which is called as day2.ipynb, and here I'm going to start coding. First, let's go ahead with a comment saying what I'm doing here, storing a name in a variable. So if I want to do that, I'm going to create a variable called as name and store a name inside there, like my name, Vivian. I can go ahead and say storing an age in a variable, and this one I'm going to say age equal to 42, my age. Now name stores the string Vivian here and age stores the integer 42. Now some of the variable naming rules include you must start with a letter or an underscore like this, either name or underscore like that. That's how you can start. Cannot start with a number. You can't say 9 name. That is not right. It can only contain letters, numbers, and underscores. And it is case sensitive. So name is different from name. These are two different variables, just FYI. So you have to make sure that you know what you're writing and what you're using. Some of the common conventions that you can use is make sure that you always start your variables with small letters and name of person. This is called as camel casing because it starts from small and the next word in here of starts capital and the next one is capital again. So it's up and down. So that's why it's called camel case. There's also capitalized camel case, which is starts with a capital letter. Again, anyway, you'll probably see all these different examples as and when we go forward for creating variables. Next, let's talk about data types. Python has different data types for storing different types of information. Different ones that we know are strings, which actually has text enclosed in quotes. We have integers, which are whole numbers, we have float, which are decimal numbers, and we have boolean, which are true and false values. So let's go ahead and look at these examples. I'm going to create a new code snippet here, and I'm going to say for string, I'm going to call name equal to Vivian. This is a string with data type. Next, for integer, I'm going to say age equal to 42. This is integer. Next, I'm going to say float. This is, let's say, height is 5, 8, something like this. And for boolean, I have, let's say, is underscore student equal to true or can be false. So these are true values, either true or false. These are the values that a boolean has. Now, next, you can also check for a variable's data type. For example, I can run this here. Nothing's going to happen because it doesn't print anything or do anything, but this will create these variables and store it in memory. Next, I want to check a variable's data type. You can use something called as the type function to check the data type of a variable. For example, I can say print what is type for name, for age, height, is student. What is the data type for these? And now when I run it, it will go ahead, create these variables, and then print me. First one, name is of the class string. Age is int, which is integer. This is float, and this is boolean, which is displayed as bool. Next, let's look at type conversion. Now sometimes you need to convert one data type into another. Example can be converting a string into an integer. So for example, I go here, I create a new code snippet, and I'll say age equal to 42. Then instead of this, I have here, let's say, in string. So you got age from somewhere, but this age is stored as a string. So I'm going to say age equal to int of age. What it does is it converts age to an integer in this case. I'm going to say in here, instead of doing this, I'll say my age equal to, so now my age is an integer and it will convert the string into int. And now I can say print age, or let's say my age plus 5. So when I run this, what it does is it creates this string and then it converts this into an integer here because I've used this int, and then adds that 42 to this. But if I just use age here and say plus 5, in this case, it will give an error saying that you're trying to add a string to an integer. That's not right. So sometimes when you want to do these calculations on values that are saved as string, you can convert them into int and then go ahead and use that and run it, and now it's fine. So there's different types of conversion functions. What you've seen here is one of int. We have something similar for float. We have something similar for converting to a string, and we have bool. So these can convert from whatever type they are to a different type. So we have int, float, string, and bool. Now next, let's make sure this is fixed. I don't want to have something wrong. And next, let's look at string formatting. Now we've already seen f strings, but there are three main ways to format strings in Python. First is using the plus operator. Next, we have dot format, which you've probably seen that Google Colab was trying to help me with dot format. And the next is using the f strings, which is the recommended way for string formatting. So let's go ahead and look at, first, I'm going to move this up, and let's say I have name equal to Vivian, and then I want to say print hello, comma, and as it was showing me, plus name plus, there you go. So this, what it does is it takes hello and then takes this variable, whatever the name inside it is added here and displayed in nicer format in a single line. That's what plus does. It adds strings together, or something called a string concatenation. Similarly, I can do something like print hello, comma, and then I'll say this will contain a variable here, but that I want to add format name something like this. So what it does is wherever it finds a curly braces, it will take this value and put it inside there. So if I run this, and this time I'm gonna make it a little different. Hello, my friend. Run it so you can see the difference between the two. I say hello Vivian, and this is hello my friend, comma, and it will put that name inside here. Another method is, as I mentioned, the recommended method is f strings. So for that, I'm going to say print, there you go, hello, and then the name. I'll run this, and you'll see hello Vivian for the first one here with plus signs. Next is with format, where it formats, puts the name inside the curly brackets, and you can create bunch of different curly brackets and keep on adding the values in here, and it will format it nicely. And the last one is f strings, where you put an f in front of the double quotes, and then wherever the curly bracket is inside that, give the name of the variable. So f string are the most modern and readable way to format strings, just FYI. That's why it's the recommended one. Now, going forward, our final step is our day two project, which is personalized greeting program. The goal here is to build a Python program that asks the user for their name, age, and favorite color. Yesterday, we did name and hobby, but today we're going to do name, age, and favorite color, and then generate a personalized greeting message. So let's go ahead, move it up, create a new code snippet, and here I'm going to first start with personalized greeting program. Call it that. Our step one here will be to ask for user details. Now I'm going to say name equal to input. What is your name? Next, I'm going to take how old are you, but this is age and user will enter a number, so I want to convert it into an integer. So I'm going to put that int function that we learned today here. Next, I want to know user's favorite color. I'm going to say input, what's your favorite color? That's what I'll add, and then I'll greet the user, or I'll say generate a personalized greeting message. And here, as you know, I want to make it more fancy. I'm going to say print, and I'll say slash n dash dash dash, and I'll say personalized greeting. Oops, not all the things, but why not? I'll add name, and just as yesterday, I can go ahead and add an emoji here of wave, and I'll say you are dash years old, and I'm gonna just add everything here. Color is a beautiful color, so depending on whatever the user enters, and then here I am going to say you are now ready to start your Python adventure. Perfect. Close it. So there you go. We have our stuff. If you want to add some more emojis, you can always go ahead and add emojis of rocket and the Python here. This is not a f string, so you can get rid of that and just have it here and run it. Now, first it will ask me, what is your name? And I am going to say, my name is John Doe. Say, how old are you? I'll say 27. What is your favorite color? And I'm going to say red. It says, hello John Doe, you're 27 years old and red is a beautiful color. You're now ready to start your Python adventure. And so are you, my friend. So now that you have this ready, or if you get this working, that's great. If not, let me know in the messages. And just to go through the project here, we did input collection where user enters their name, age, and favorite color using the input function. We did data conversion where age is converted to an integer using int, because user enters whatever user enters is taken as string. Input takes values in string, and then we converted that into integer. Then we did some dynamic message generation. We used the f strings here to format and display the personalized greeting. And finally, presentation. As for presentation goes, we added section titles like using slash n here, and we improved the readability, and we added some emojis right at front and bottom here, and I hope you are able to follow along. But if you have any questions, let me know. Now, bonus challenge for today is ask the user for their birth year and calculate their current age instead of asking them to enter the age. You can create a nickname generator based on the user's name, and you can also try to display the user's age in months, weeks, and days. So have fun with that and let me know how it goes. And if you have any questions, let me know about it and I'll get back to you. Welcome to day 3 of your 100 days of Python challenge. Today, you'll master user input and string formatting while building a simple calculator that can perform basic arithmetic operations. By the end of the day, you'll have a Python program that takes user input, processes it, and displays results in a clean and formatted way. Let's see what you learned today. You learn user input with input, type conversion with int and float, string formatting with f strings, basic arithmetic operations, and our day 3 project, which is simple calculator. I know we are repeating a lot of things that we did in the last 2 days, but it's just for better practice and to understand properly what they actually do, and it will help you in future. So let's start with user input with input function. The input function allows users to type values into your program. So let's go ahead and in day3.ipynb, I'm going to start coding here. I'm going to say name equal to input, enter your name. Give that prompt to the user, and then I will say based on what user enters, I am going to say hello name, no age, sorry. This is just name. And as I mentioned, instead of using this, what they've provided us, I'm going to say f hello and name here. Perfect. So I'm going to use f strings here. So what we are doing here is in input function, it takes user input and stores it in the variable name, and then the print function displays a dynamic greeting using the f string. If I run this, it's going to take a little while, first time since I'm running it, and it will say print hello, whatever the name is based on what I enter when it asks me the question. Here you go. Say Vivian, and it says hello Vivian. There you go. Next, to jump into type conversion, we'll be looking at int function and float function. Now by default, input function returns everything as a string. If you're collecting numbers, you'll need to convert the string into integers or floats depending on what type or what you're looking for. So for example, I am going to say, let me create a next code snippet. I'm going to say number1 equal to input, enter a number. Okay, I'm just gonna ignore what it's asking me to do. This is a string. Whatever I get here will be a string. If I say num1 equal to int of num1, so whatever I get above, I'm converting that into an integer this time. So initially it was string, now it is an integer because just this int function will convert whatever I have into an integer. I'm going to say print f of number doubled is num1, whatever the number is, times 2. So that's the doubled value of this. If I run this here, it will give me, let's say if I say 10 here, doubled is 20. So the int function here converts whatever I get here into an integer. Next, if I want to do something similar with a float, let's say a float, they'll convert into float and then double it into in here. So I'm going to run it, and this time I'll say 12.4, enter, and then it will take that number, convert into float, and then double it by multiplying it by 2 right here. Now if I call string here and run it, and I'll say 12, and it says, if you see here, what it did was it took that number which is 12 times 2. What it did was, since it's a string 1 2, it doubled it by saying 1 2 1 2. That's what it did with this particular function, where I entered a number which is 12. It took it as a string. It was a string already, so I didn't have to convert it. But if I had taken it as integer and then converted it, it did the same because this number is now converted into a string, and when I say double it will double that string. That's what's happening here. Next, let's look at string formatting with f strings. Now, we briefly covered f strings before, but they become even more useful when displaying results dynamically. So for example, here I'm going to create a new code snippet, and I'm going to say num1 equal to integer of, let's say, whatever the input user enter a first number, and num2 integer input enter second number. I'm going to just call it first number and second number, and then I'll say result equal to num1 plus num2, and then I'm going to say print the sum of num1 and num2 is result here, something like this. And now when I run it, it will ask me, let's say 12 and let's say 8. 12 plus the sum of 12 plus 8 is 20. So this is more readable, it's easier to understand than concatenating strings, and it's dynamic. You can include variables directly inside the string. So that's why f strings are recommended, and it's very powerful when you use them to print out things. Next, let's look at some basic arithmetic operations. In this particular section, we'll look at what all different arithmetic operations that Python supports, which are addition, subtraction, multiplication, division, then there's floor division, and then there's modulus and exponentiation. So addition is adding two numbers, subtraction is subtracting, multiplication, multiplying, and division is division, that you're probably already familiar with. But there's something called as floor division, which will, for example, 5 divided by 3 will give you 1.666. But if you say 5 floor division 3, it will give 1. It will drop everything else after the decimal place. It will floor the number. Then we have modulus, which is 5 mod 3 will give you 2, because that's the remainder after the division operation. So that's what modulus gives you, the remainder. And then you have exponentiation, which is, let's say, 5 exponentiation of 3 will be 125, because that's 5 raised to 3. That's what exponentiation means. And let's look at an example here. I'm going to go here and say a equal to 10 and b equal to 5. Now I can say print of f of addition is a plus b, subtraction, multiplication, division. Now I also want to do, what did I mention? Floor division, modulus, and exponentiation. So floor division is double slash slash instead of single division. That's why it's floor division. Modulus is mod, and exponentiation is a raised to b, which is, in this case, I'll close it, 10 raised to 5. So whatever that is going to be displayed here. So let's go ahead and run it. So as you can see, a plus b, 10 plus 5 is 15, 10 minus 5 is 5, multiplication 10 times 5 is 50, division 2 is 10 divided by 5 is 2.0. In this case, floor division will also be 2, because if you drop the decimal, there is nothing but that. Modulus is 0, because 5 times 2 is 10 and there's no remainder, so that's why 0. And exponentiation is 10 raised to 5, which is 5 more zeros added at the end of it. So that's what you get, which is 100,000 in this particular case is what you get for exponentiation. Now similarly, as I mentioned, if I want to see another operation, 5 and 3, run it. Addition will be 8, subtraction 2, multiplication 15. Division is 1.66667. Floor division is just 1. It drops everything after decimal place. Modulus is 2, because 3 times 1 is 3 and then 2 is remainder, and that's what we get. Exponentiation is 5 raised to 3 is 125, and that's what we get for exponentiation. So keep this in mind. It will be very helpful for our next topic, which is our simple calculator. Now the goal here is to build a Python program that takes two numbers from the user and performs basic arithmetic operations. We'll just focus on addition, subtraction, multiplication, and division. So let's go ahead and build this project. So first step is, let's create a code snippet here. And I'm going to say this is a simple calculator calculator. Next, I am going to say step 1 is get user input for two numbers. I'm going to say number 1 equal to float of input, enter first number, and number 2 is float input, enter second number. Now our step 2 will be perform arithmet- arithmetic operations, and for that I'm going to say addition equal to number 1 plus number 2, subtraction, multiplication, and division is what we have. Now in per case of division, what if you try to divide by 0? So what I'm going to do here is I'm going to check if number 2 is not equal to 0, else I'll say cannot divide by 0 is what will be given as the output here. So finally I will go ahead and here I am going to say print. I think it understands me a little better now, but I'm going to say calculator results dash dash dash, nicely formatted, and I'll say addition is this, but I can also say here addition of number 1 plus number 2 is equal to this, something like this. I want to do this, so that means that even for this is negative, this is multiplication x, and this is division. So I have addition, subtraction, multiplication, and division all displayed here and being printed out. So let's go ahead and run our simple calculator code. So first it will ask me for numbers. I'll say 12. Second number, let's say 4. So it will tell me 12 plus 4 is 16, 12 minus 4 is 8, 12 times 4 is 48, and 12 divided by 4 is 3. And there you see you have your calculator results out here. Perfect. So let me know if you had any issues with this. But just to go over this project, we did input gathering first, where we took two numbers from using the input function, and then we converted them to float for decimal precision. And then we did some arithmetic operations. We did addition, subtraction, multiplication, and divisions. And we have a very dynamic display here. Results are displayed using F strings for clarity, and we have a nice user-friendly interface which improves our readability, which shows you the results by separating out the input and the display part right here. So again, for a bonus challenge for today is you can add an option for user to choose the operation. Instead of doing all the operation, you can say choose the operation plus, minus, multiplication, division, and then handle division by 0 with a custom error message this time, and try to add exponentiation and modulus operations in your calculator too. So let me know how that goes, and if you have any questions, let me know in the messages and I'll get back to you. Welcome to day 4 of your 100 days of Python challenge. Today you'll master conditional statements in Python, especially if-else statements. By the end of the day, you'll have built a number comparison tool that compares two numbers and gives meaningful feedback. Let's see what you'll learn today. First, what are if-else statements? Next is comparison operators. We look at logical operators then, and then we look at nested if-else statements, and finally we'll do our day 4 project, which is number comparison tool. Now first, what are if-else statements? They are conditional statements that let your program make decisions based on specific conditions. Now let's look at a basic syntax. So I've created a day 4 file here, and here I am going to say if condition, this is the syntax, colon, and then I'll say do something if the condition is true. For example, if it's raining, get an umbrella. If not, else do something if the condition is false. So if it's not raining, get your shades out. So that's what I'm doing here. Similarly, if one is bigger than, if let's say you have two variables which are entered, 10 and 22. Now if you say 10 is bigger than 22, then do this, which is not true, which means it will run the else statement and do whatever you ask the computer to do here. So let's look at a simple example here. So let's say I have a number which is 10 equal to 10. Now I am checking if number is greater than, let's say, 5, then I will print the number is greater than 5. I'm not going to do else if, I'm just going to say else print the number is less than 5, something like that. So in this case, if I run it, you know what's going to happen. 10, the number is greater than 5, so it will say the number is greater than 5. Number is greater than 5. If I change this value here and give it 4 and run it, now in this case 4 is less than 5, so this will not run, it will run this part and it will say number is less than 5. That's how if else works. Now there's also else if. Else if I can check number is equal to 5, the number is equal to 5, and if it's not greater or equal, then it's less than 5, something like this. In this case it's less than 5, but if I give value as 5, let's say number is equal to 5, then it will run this one. If I say number is 6, which in case will use the first one and run that one. So this is if else statements. Next, let's look at comparison operators. Now comparison operators are used to compare values in an if statement. So we can compare equal to, not equal to, greater than, less than, greater than or equal to, less than or equal to. We have already used here greater than or equal to comparison operators, but then you can also use, as I mentioned, less than equal to, then there is as I mentioned, not equal to, which is not equal to, or equal to, which is double equal to. When you give single equal sign, it means equal, you're assigning some value, whereas when you use double equal, you're comparing. And this operation where you're saying number equal to, is it equal to 5? That's what I'm saying. And if it's true, it will run this. If it's not true, it will run something else. So I'll keep it what it was before. Number is greater than 5, then do this. So these are your comparison operators. So there's a bunch of different ones and we'll be using them quite a lot in the following days. So let's go ahead. Next, we have logical operators. Now logical operators allow you to combine multiple conditions where you can say if something is less than 5 and greater than 2, something like that, or you can use or and you can use not. Let's look at an example. So let me create a new one this time. I'm going to say a equal to 7 and I'm going to say b equal to 12. Now I'm going to check if a is greater than 5 and b is less than, let's use this, 15. I will say both conditions are true, and then if not, print at least one condition is false, which means at least one of them might be false or both will be false. So in our case, a is 7 and b is 12. So is a greater than 5? That's true. And is b less than 15? That's true. So both conditions are true, should be our output here. So both conditions are true. But if this is 20, in this case, at least one condition is false, which is this is true, but this is false. So and will check, have to make sure that both of them are true, or else it will not run this particular statement here. If both of them, if either or both of them are false, then we'll have this one. So for example, if I have 3 here, so even this is false and this is false, so at least one condition is false. Whereas for or, it has to be one of them has to be true. So if I change this to what it was and I'll say or here, at least one condition is false. In this case, if I run this, I mean both, if a is greater than 5 or b is less than 15. It says both conditions are true, which is not true, which is either one of them are true, and this will run when both conditions are false. So let's do some grammar correction. But in this case, a is greater than 5, that's true, or b is less than 15, that's not true, but it's a either one of them is true. So because this one is true, it runs this. But if this and both of them, let's say a is 2, 2 is greater than b, nope. In this case, both conditions are false, it will run that. So and or works that way. Next, let's look at nested if else statements. Now you've seen if else, but you can also nest if else statements inside each other for more complex decisions. And that was using else if, but you can also nest more inside them. For example, let's go back here to the previous one where we have nested statements where I'm saying number is greater than 5, it is. So say number is greater than 5. If I have 3, is number greater than 5? Nope, it's not. Number is less than 5? Nope. And then if number is less than 5, you have less than 5. So you can kind of nest your if statements with else ifs and keep on adding more and more else ifs. I can check else if number is equal to 4, then I can say is equal to 4, something like this. In this case, it will say number is less than 5, but if I say number is 4, run it, say number is equal to 4. So you can keep on nesting it and have multiple operations, or depending on what you want to check or what you want to find, you can go through these nested if else statements. Next, with all that we have learned today, let's jump into our day 4 project, which is number comparison tool. The goal here is to build a Python program that takes two numbers as input and compares them, check if the numbers are equal, identify which number is greater, and determine if either number is 0. So let's go ahead and write that code. So I'll go all the way to the bottom, add another code snippet, or let's say delete this, go back here and add at the bottom. So here first let's specify what we are doing. I'm going to create a number comparison tool. Next I am going to say my step 1 is to get user input for two numbers. So I am going to say number 1 equal to float of input, and then I will ask the user enter the first number and then enter the second number as number 2, and thanks for helping me out. And then I'll say step 2 is compare the numbers, and I'm just going to say compare the numbers. And here first I will, I like to add some separation, so I'll say slash n dash 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 comparison results dash dash dash, and then I'll check if number 1, first I'll check if number 1 equal to number 2, then I will say in this case both numbers are equal, and I'll just pass number 1 because if both numbers are equal, that's the number. Else if number 1 is greater than number 2, then I will say this number is greater than the second number. I'll display that. Else I'll say the second number, the first number is less than the second number. Or I can do the same thing that I did here and then switch them. Number 2 is greater than number 1, something like this. Now lastly I said let's check if the number is 0, so I can say step 3 check if any number is 0. So for that I'll use that or logical operator, number 1 equal to 0 or number 2 equal to 0. I'll say at least one number is 0 and both numbers are non-zero. if not true. I don't have to do this last part, but why not? Since it's recommending me, I'll add that. So I'm going to go ahead and run this. So I'm going to say first number is 8, second number is 5. So I'll say comparison result 8 is greater than 5 and both numbers are non-zero. I can run it again, say 5 and 0. Say comparison result 5 is greater than 0, at least one number is 0, which is our second number, which is 0. So that's an example of our number comparison tool. I hope you were able to follow along. Again, just to go through the project breakdown, we did some input gathering where we took two numbers using the input function and converted them to float. We used if else to compare the numbers and display the results. We used or to check if either numbers are 0, and we gave you used f strings for clear and user friendly messages. I hope you were able to follow along, and if you were, a bonus challenge for you for day 4 is add an option to compare three numbers. Check if both numbers are positive, negative, or 0, and then include an option for the user to run the program again without restarting. So let me know how it goes. If you have any questions, let me know in the messages and I'll get back to you. Welcome to day 5 of your 100 days of Python challenge. Today, we'll master loops in Python, specifically for loops and while loops. By the end of the day, you'll build an interactive countdown timer that can count down from any number you provide. Let's look at what you learned today. First, what are loops? Then we will cover for loops and while loops using time.sleep for delays, which will help us in our day 5 project, which is countdown timer. Now first, let's go through what are loops. Loops are used to repeat a block of code multiple times. There are two main types of loops in Python. First one is the for loop, which repeats a set number of times, and then we have while loop, which repeats until a condition becomes false. So let's look at for loops. The syntax for loop is something like this. Let's go ahead and create, if you have not yet created your Google Colab or you prefer to open your own IDE or work with something else, that's fine. What you're going to do is create a day 5 project, and then inside here I'm going to start coding. Now the syntax for loop goes something like this: for variable in the range of, and this range function takes three parameters: start, stop, and then step. Now in here, the start is the starting value, default is 0 by default, and stop is the end value which does not included in the range, and step is how much to increment by, and the default is 1. Let's go ahead and write a simple for loop for here. So this is the entire syntax, and this is where the code to repeat will go. So this is the for loop syntax. Now if I want to create something like this, I'm going to go create another code snippet and say example here is for I in range of, I'm just going to give something like 5 because I don't want to give the start. As I mentioned, the start default is 0, and if I say 5, it will go from 0 to 5 but not included. This top value is not included in the range, so it goes until 4, and the step by default is 1, so I don't want to give step, so I'm going to increment from 0 to 5, and then I am going to say inside my loop I want to just print the value of I. Now if I run it first time, as you know, it takes time, but what it will do is it will go through each and every value, assign that value to I, and then pass it to the loop below. So first the value in the range is 0, so I's value is 0, and then that's why it prints 0 here. Next, increments by 1 because the step by default is 1, so it will go and pass that. So this would, if I want to give all the default values, this is how it would look like, where it would go from 0 to 5 and pass that value for it to print here. Next, let's look at an example for the reverse loop. So in this case, I have 0, 5, 0, but I can say 5, 0, and I want to go in the reverse order. So I'm going to say -1 here. If I run this, it will go 5, 4, 3, 2, 1. So this is how you can run your reverse loop. Again, as you see, 0 is not included in here because it starts from 5 in this particular case, reduces by 1, 4, 3, 2, 1, and as soon as it gets to 1, it gets out of the loop, and in this case stops the function. Next, let's look at while loops. To start with, let's look at the syntax for while loop. I'm going to create a next code snippet here, right here. And in here, just to look at the syntax for while, it's while a particular condition is true, it will code to repeat goes in here. This is the syntax for while. So you give a particular condition, more like something that you've done in if else, where you can give a condition if x equal to 5, something like that, and then keep on repeating this loop. I can give you an example here. So let's go ahead and do something that we did above, where I'm going to say count equal to 5, and then I'm going to say while count is greater than 0. Now if you look at the value of count right now, when it executes, it will say count is greater than 0. Yes, why? Because the value of count is 5. So I'm going to say if it's greater than 0, then run this loop where I will say print count, whatever the value of count is, and count minus equal to 1. This is the decrement operator where I reduce the value of count by 1. So it runs through this and then again compares. What is the value of count? Since we decremented, now the value of count is 4. Is it greater than 0? Yes, it is. Print 4. Then it decrements again, goes to 3, 2, 1. And then finally it will go to 0 and it will say 0 is greater than 0. No, it is not, because 0 is equal to 0 and it will stop the loop. So let's run it. And as you can see, 5, 4, 3, 2, 1. Okay, it starts with 5, prints that, and goes in the opposite direction. Now, if I want to do this same thing what we did above in a reverse direction, I can just say count equal to 0, less than 5 or less than 6, whatever you want to prefer, and increment the value. In this case, it will go from 0, 1, 2, 3, 4. So this is a reverse while loop. Now you have to be cautious about what you do in here. For example, if you never increment the value, it will go in an infinite loop because the value of count is equal to 0, which is less than 5 at all times. It's just going to say print 0, 0, 0, 0, 0, 0, something like that, and it will go on infinite loop until you run out of memory and you'll have to do something like Control C in the terminal to stop the application. Next, let's look at using time.sleep for delays. Sometimes you want your program to pause for a moment between iterations. There, you use something like as time.sleep. Let's look at an example here. So I'm going to go here, create another code snippet, and inside here, I am going to first import time because that's where the sleep function exists. As you see, time.sleep. So this is a module that I'm importing, which is available with Python. And then I am going to say for I in range of 5 comma 0 comma minus 1. So I am decrementing the values, and here I am going to say print I, and then I will say time dot sleep for 1 second. So this will pause the program for a second, and then it will say happy new year. So let's go ahead and run it. It's a 5, 4, 3, 2, 1, and happy new year. If I don't give this, what will happen is it will run as fast as possible and give that value. But just adding this time dot sleep, if I increment by 2 here, and then here I'll say 10, and then say minus 2, can go 10, wait for 2 seconds, 8, wait for 2 seconds, 6, wait for 2 more seconds, 4, wait for 2 more seconds, 2, wait for 2 more seconds, and happy new year. There you go. So that's how this time dot sleep works. Now, why do you use time dot sleep? One, to slow down your loop for better visualization. You can look at how you debugging your program to see what's happening, and then sometimes to simulate real-time processes like timers, which we have done in this particular case. Now that brings us to day 5 project, which is countdown timer. The goal here is to build a Python program that takes a countdown starting number from the user and counts down to 0, showing one number at a time with a 1 second delay. And you probably know all the steps that I've spoke about right now. So let's go ahead and implement it. So I'm going to go ahead and say new code. I'm going to move it all the way to the top, and I'm going to give a comment saying it's a countdown timer, and then I'm going to import time. As you know, we need that for it to go to sleep for a second. Our step one here will be to get user input for countdown start. Now you've done this input, taking users input before. If you're not, I would recommend you to look at the previous videos. So I'm going to say start equal to int. I'm converting the string value that input gets me into int, and I am saying input. Now ask the user enter the number to start the countdown from, and that will ask a user, give a user a prompt saying that please enter the value. And then I'm going to say step 2 in this case is countdown using a while loop. That's what I'm going to run here. So to start with, I'm going to again make it pretty by saying slash n, a new line, dash dash dash, and say countdown begins, dash dash dash, close it, next one, and then I'll run my while. Again, it's helping me here while start is greater than 0. So I'm going to check users input if or the current value of start, is it greater than 0. I'm going to say print start and then make it sleep for 1 second, and then I'm going to reduce it by 1 second, again -1. So whatever the value is, let's say user says 5, so it will display 5, -1, 4, 3, 2, 1 until it gets to 0, and then it will go out of this while loop, and step 3 will be print not happy new year final message. And there I can probably say here something like countdown complete. Okay, there you go. So that's my entire code. If I run this now here, it goes through first steps where it's asked enter the number to start the countdown, and I'm going to say 5, press enter, goes through the loop, 5, 4, 3, 2, 1, and countdown complete. There you go. We have our entire application done here. So if you had any issues here, let me know and I can help you out. But if just to go over the entire project that we did today, first we did the user input where we used input function to get the countdown starting number. Then we converted the input which comes inside as a string into integer and assigned it to start here. We used a while loop to decrement the countdown number, and we used timer.sleep1 here to pause for 1 second between each iteration, and then we displayed a final celebratory message after the countdown finished saying that countdown is complete. Now for the next steps, if you want to do a bonus challenge for day 5, allow the user to choose the countdown speed. Instead of manually entering this, ask user how much speed do you want. Do you want half a second, 2 seconds, 5 seconds? Instead of 1 second, you can ask the user for what countdown speed they want. Add a custom message at the end of the countdown. Instead of this, add some emojis, make it fun, and display halfway there when the countdown reaches the halfway point. That's the next part you can work on. So try it out, let me know how it goes, and if you had any issues, let me know in the messages and I'll get back to you. Welcome to day 6 of your 100 days of Python challenge. Today you'll learn about functions, one of the most powerful tools in Python. By the end of this lesson, you'll build an interactive basic math quiz game that asks random math questions, checks answers, and gives a score. So what you'll learn today is first, what are functions, defining and calling functions, function parameters and arguments, return statements, and finally our day 6 project, which is the basic math quiz game. Now let's go to what are functions. Functions are reusable blocks of code that perform a specific task. They help make your code cleaner, modular, and reusable. Now, why use functions? First, to avoid repetition. You write once and use many times. One of the examples is print function that you've been using. It's written once by Python team and you're using it continuously to print values. Also, another one is input function. Another reason is modularity. You break large tasks into smaller ones. And finally, readability. It's easier to understand and maintain code when you write your code in functions. Now let's talk about defining and calling functions. Let's look at the syntax of a function. So I have day6.ipynb, which is interactive Python notebook. And here I'm going to start with defining a function by saying def is the keyword, and then you give the name of the function. This is the syntax of how a function is written, followed by a colon, and then here is your code block inside the function. So this is where you can write your code. For example, if I want to write print hello from the function. Now the thing is, if I run this particular code, it will not print anything because nobody is calling this function. So nothing is going to happen in this particular case unless this function is called specifically. For example, if I go outside, so here is outside the function, I can say function underscore name, and this will call the function. So this will call the function and it will run through the code inside the function and print this hello from the function print statement. Let's look at an example. So I'm going to go ahead and write a proper example. Now let's say I want to create a function and call it greet. I would never call a function name function name. This is just to show you the syntax. But let's say greet, and here I am going to say print hello, welcome to Python exclamation mark. And now if I want to call this function, I will be calling it from outside by saying greet, and then when I run it, it will call this function and this will execute and it will print this hello, welcome to Python print statement. Now next, look at function parameters and arguments. Now you can pass data into a function using parameters. So how do we do that? So if you see here, this is a function call, and inside this you can add parameters. One example is, you can go here and I recreate the same function. I'm going to call it greet underscore user, and then inside here I'm going to say print hello, welcome to Python, something like this, and I'm call that function. But now I want to say that I want to greet this person Alice with her name. So in here I can say that this particular function takes arguments or parameters, and that is what you specify here. So what happens is when it calls this, it takes this value and assigns it to this variable, and then inside here I can just say name exclamation mark, but again this needs to be an f print statement, so f string. So there is my f string, f hello, and then give the name of the variable in here inside curly brackets, and then now when I run it, it's going to call with that name. If I change it to my name, run it, it will say hello Vivian, welcome to Python, because it replaces this variable's value with the variable that I pass, and that's what parameters are. Now you can give more than one parameters. Another example I can show you is, for example, I want to create a function to add two numbers. I can say add two numbers are a and b, and I am going to say print f string the sum is, and I'll do the math operation here as it showed me how to do it. A plus b, something like this, is my math operation. So it will run this code and make sure that this value is printed outside. So now if I want to call this function, I can just go outside and say add 3 comma 4, and these values are assigned to 3 is assigned to a and 4 is assigned to b, and when I run it, it says sum is 7. If I change this number to 5 plus 4 is 9, the sum is 9, and that's what's printed out here. So that's how parameters work, and you can have as many parameters as you want added to this particular function name right here. Next, let's look at return statements. Now functions can return values using the return keyword. Till now what we did was we called functions and we didn't get anything back from it, but you can actually get data back from a function. So for example, I want to multiply two numbers. Let's call it multiply, and then I pass a and b as parameters, and then this will, so usually I can just say print, but I can say return a times b. What it will do is it will do the multiplication here, and whatever the value is, it will return to whoever called this function. So if I go here and say result equal to multiply, I call that function, give it two values 5 and 4, and then I'll say print. I'll make it a little bit more prettier. The result is comma result. So this will first call the function 5 and 4. This will multiply 5 times 4, which is 20, and then return back the value to this function which called it, and assign it to this value here, variable here, result, and that will be printed out. If I run this, it will say the result is 20. So that's the power of the return, and we will be using this quite a lot in our videos in future. So let's go ahead and look at what's next. So this brings us to our day 6 project, which is a basic math quiz game. The goal here is to build a Python program that asks the user random math questions like addition, subtraction, multiplication, takes user inputs for answers, and tracks the score and gives feedback. So let's go ahead and write this code. So I'm going to go ahead in the same notebook. I'm going to create another code, move it all the way to the top, and again start with our comment saying basic math quiz game. And then I'll go to the next line and I'm going to import something called as random, because I will be creating some random numbers. So I'm going to say step 1 is to define the math question function. Here I'm going to generate a question, and I'll be using the random library. So I'm going to say first number 1 is random dot rand int 1 to 10, and number 2 equal to random dot rand int 1 to 10. So this will give me two integer numbers and assign to this variable. Next, I'm going to say operator equal to random dot choice between plus, minus, and multiply. So I'm going to pick either three of them. Just to make it easier, I'm not going to involve division here, but I am going to say random dot choice plus, minus, or multiplication. And then I'm going to write if operator equal to plus, then answer equal to number 1 plus number 2. Else if operator is minus, is that what user selected, then answer is this. Else the answer is number 1 times number 2. So that's my entire operation. Now this is what I will return back to whoever called it. So I'm going to say f, I'm create a f string, number 1 operator, and then number 2. That's what I've done. Yes, operator number 2. So depending on what it is, this will be the operation, and then I'll also pass back the answer. There you go. So these are the values that I'm passing. Now let's go ahead and write the main quiz game. So here, where is step 2 is the main quiz game function. In here, I'm going to say create a math quiz, and inside there I'm going to say score. I'll keep a track of user score, and then I'll say let's set some rounds. You can change this depending on how you want it. 5. First I'm going to say, as I like it, welcome to the math quiz game dash dash dash, and then so you'll be presented with math problems and you need to provide the correct answer. That's perfect. So that's what I'm doing here. So now here I'm going to say for I in range of rounds. So depending on how many rounds we have selected here, which is 5 in our case, I am going to say question comma correct answer equal to generate question. It's going to generate that question and give me back the question, which will be assigned to question, and the answer, the correct answer, will be assigned to this correct answer variable. So you can return back two variables which we have done here. One is a string here and one is the actual answer. And then I'm going to pass that question. I'm going to print here question I plus 1, which is depending on which operation I'm running. I'm going to say this is the question which will which will ask user whatever the first number is, operator the second number. Now once that is done, let's go ahead, and our next step is let's take user's answer. User answer equal to int input your answer. So I'm taking user's answer as string first and then converting it into int and saving it into a variable called as user answer. Now I'm going to check if user answer is equal to correct answer, I'm going to say correct and increment the score. Else, I'll say wrong and I will say the correct answer is this correct answer. I'll show him what the correct answer is. I'm not going to reduce scores for it, but I am going to increase score based on if they give a right answer or not. Next, once the entire game is over, so let's say here outside the for loop once, so this is going to run for 5 times because I've said round equal to 5. So it's going to run for 5 times. And then once it's over, I am going to say print game over, print your final score is whatever the score is divide by the rounds. So that's what I'll be displaying here. If and then before running this, I am going to check if score is equal to rounds, I'm going to say congratulations, you got all the questions correct. Else if score is greater than equal to rounds, I'm going to use the floor division, which will floor the value depending on the division value, and say good job, you did well but not the perfect score. Else I'll say keep practicing, you can do better next time. And then finally I am running the game here by calling this math quiz function. So what happens here is it will first, since there's only two functions here, nothing is going to run. When I press play, it's going to go through this, and this is the first line it will execute. It will say math quiz, call the function, this one. It will start with this, and it will first generate a particular question based on this function, and then have the question which will be presented to the user. I will take user's input, and depending on user's correct answer, is user's answer is same as correct answer, I'll say print correct, increment the score. Else it will say wrong, and not increment the score but keep the scores same. And then finally it will print out the results. So let's go ahead and run this program. Press play. It says what equation 1, 7 plus 4, and I'm going to say 10 even though I know it's wrong answer, and it will say wrong, the correct answer is 11. Next it says 5 minus 4, and I'm going to say 2 in this case again. The correct answer is 1. 9 times 5, this time I'll say 45. It says correct, that's right. 4 times 3, I'll say 12. And now it says correct. 8 minus 1, I'll say 7. And it's correct. It says your final score is 3 out of 5. Good job, you did well, but you can do better. Again, if I give anything that is, let's say 5 rounds mod divide by 2, that is 2.5, that is less than the score. So what I'm trying to do is I want to make sure that the user gets at least half or more answers right. Again, if I run this again, and then I'll say randomly, oops, I think that answer was 1. It's trying to give all the wrong answers. And then it says, in this case, 1 out of 5. So that's why I'm saying you can do better next time, keep practicing. So that's our entire project to build a basic math quiz game. I hope you were able to follow along. If you have any questions or doubts on this, let me know in the messages and I'll get back to you. But just to go over it, we created two functions. One was the generate question, which generates two random numbers and a random operator and calculates the correct answer. Then we did the math quiz, which loops through multiple rounds of questions, checks if the user's answer is correct, and tracks and displays the score. We also do user feedback where we give immediate feedback on each answer, and then we display the final score and encouragement message depending on how the user does. The bonus challenge here for your day 6 is add the division as operator. In here I've only done plus, minus and multiplication. Allow the user to choose the number of questions. So we have set the rounds to 5, but ask the user to select how many rounds he or she wants to play. Next, include a timer to limit how long each question can be answered. You learned that in the yesterday's project. Try that out and add that timer here. And if you have any questions or had any issues while implementing this, let me know in the messages and I'll get back to you. Welcome to day 7 of your 100 Days of Python challenge. Today, you'll master Python list, one of the most versatile data structures in Python. By the end of the day, you'll build an interactive shopping list app that allows users to add, remove, and view items in a shopping list. Let's see what you learned today. First, what are lists? List operations like adding, removing, and accessing items, looping through lists, list methods, and finally our day 7 project, which is the shopping list app. Now let's jump into what are lists. A list is a collection of items stored in a single variable. Lists are ordered, which means items have a specific sequence. They are mutable, which means you can change, add, or remove items. And they are indexed, which means each item has an index starting at 0. It's like they are all numbered. So let's go ahead and look at an example of how to create a list. I'm going to start with a day 7 IPYNB, and inside here I'm going to say my shopping underscore list contains, so list starts with square brackets, and inside this you can add items meaning any of the data types that you learned, like strings or numbers or whatever you want. In this particular case I'm going to add strings, which is milk, eggs, and what is the third item that you need for breakfast usually? A bread. So I have milk, eggs, and bread. Now if I want to print this list, I can just say print. Come on, help me out here. Shopping, it's not completing, auto completing, so I have to type the entire thing and run it. So it creates a list here inside memory which has 3 items inside the list, which is milk, eggs, and bread. And when I say print shopping list, it will take this entire list and display it out to me. And that should be our output. Next, let's look at different list operations. Now adding, removing, and accessing items. Let's start with accessing items. You can use the square bracket, something similar what we did here, but next to the name, and you pass an index to it. Now what is the index? Index is a location at which an item is. So in this particular case, milk is at first location, second location, and third location. But the indexes start from 0, which means this is at index 0, this is 1, and this is 2. So if I say 2 in here and run it, it will show me the item at second index, which is bread. If I say 0, it will show me milk, and if I say 1, it will show me eggs. And this is how you can access items using the square bracket next to the name of the list and give the index to it. So this is how you access elements. Next, let's look at how to append or add to list using either append or the insert function. Now append adds an item to the end, whereas insert function adds an item at a specific position. So what do I mean by all these? So I'm going to go ahead here and I'm going to say shopping list dot append, and in here I am going to add one more thing, my favorite thing, butter. Now if I run it and print my shopping list without the index, I'm going to remove this or comment this out, run it, it'll say milk, eggs, bread, and butter because I've added one more item here. Another way of adding is to use insert. I can say shopping list dot insert, and in here in insert, if I want to add something, for example I want to add juice, I need to specify which index do I want to add at. Do I want to add it index 0, 1, 2, 3? So it will add it and move the rest of them outside. So not outside of the function, it will move them to the right. So for example, if I say add juice at index 1, so what it will do is it will currently have milk, eggs, bread, and butter. When I add juice at index 1, it will have milk, juice, eggs, bread, and butter. Now if I run it, you'll probably see I have milk, juice, eggs, bread, and butter. The butter was added at the end because we used the append function, whereas juice was added at the index 1 because I specified the index 1 over there. This brings us to removing items from a list. Now if I want to remove, so you can use the remove function which removes a specific item, or you can use pop which removes an item by index. So for example, if I say shopping list dot remove, in this case I'll say bread, I'll keep whatever it is, it will remove bread and it will show me that bread has been removed. If I say pop without any index here, what it will do is it will remove the last item from the list. So if I run this, You'll probably see at this point when it prints, it says milk, juice, eggs, bread, and butter. When I say remove bread, you see bread is removed and you have milk, juice, eggs, and butter. And when you say pop without anything, it will remove the last item in the list, which is from here. But if I say remove at index 0, run it again, this removed bread here. Now if you see, juice, eggs, and butter is there, but it popped out the zeroth element or index item at index 0 is been removed, which is milk in this case. And that's how you can pop items from the end or from a particular location. That brings us to looping through list. Now you can use for loops with list. So if I go here and I will comment out all these items here, just keep the ones that I have. I'm gonna keep these two because I like to have a bigger list. And then bottom here, let me actually, no, actually I have not printed, but using for loop, I'm going to say for item in shopping list, I want to print the item. In this case, what will happen is it will look at the shopping list. It has, how many items does it have? Let's see. It has 1, 2, 3, 4, 5 items. It will go through each item, assign it to item. So first it will give milk to item and print it. Next it goes to juice and assigns it to item and it prints it. Eggs, bread, and butter. That's how you can run a for loop here. You can always do something in a list format, dash space, and do it in add a, since it's a f string, you can run it. And now it is in a list format, properly in bulleted for all 5 items that are in the list. Next, you can also use enumerate. You can get both the index and the value from the list. To do that, you can go here. Let me comment this out so this is not visible. And here I'm going to say for index and item in enumerate shopping list. So this enumerates through the shopping list and gets the index. What is the index of that item? I can specify the index. What I'm going to do is I'm going to increment index by 1 because I don't want to show 0, 1, 2, 3. I want to show the user 1, 2, 3, 4. So it looks like a list of items that are there. Now when I run this, I have 1 dot item, which is milk, 2 dot juice, 3 dot x. So this looks much nicer. If I remove this plus 1, the reason I added plus 1 is it doesn't look proper if I say 0, 1, 2, 3, 4. That's good for programmers, but not for normal users. So I'm going to increment that by 1, and now it looks like a proper list displayed out. Now this brings us to something called as list methods. Now we have seen some of the list methods. We have seen methods like append. You add an item at the end in append, where you say list.append and you give the value. Next we learned about insert, which is add at a specific index. We just said list.insert and we gave the index and the item. And then we used remove, where you remove an item by value. You say list.remove and you pass the value over there. Then we used pop, where you removed an item by an index or just pop the last item by saying list.pop. There are some other list methods available like sort, which sorts the list. You just say list.sort and call the function on it. Reverse, which reverses the list. You just say list.reverse and it will reverse the list that is available. And then you have clear, which removes all items by just calling list.clear. If you want to look at them, I can run this. So in this particular case, I'm going to comment these out. I'm going to print my shopping list here. Now if you see, this is my shopping list. So we have a shopping list where we have milk, juice, eggs, bread, and butter. So I'll go ahead and say shopping list dot sort, and then I'll print that shopping list. When I do this, if I run it now, you'll see milk, juice, eggs, bread, and butter, and it sorted them say with order, alphabetical order here: bread, butter, then comes eggs, juice, and milk. If I want to reverse this list, I can just do the same thing and say reverse. Now I have to make sure that we see the difference that happens. So I'm going to print list every time before I call this function. So I sorted here, then I said reverse. That's why milk, juice, eggs, butter, and bread are reversed now. Next, I want to call a function shopping list dot clear, and I print it out, run it, and there you go. It cleared it out, and we have an empty list. So next, let's go ahead. That brings us to our day 7 project, which is a shopping list app. The goal here is to build a Python program that allows users to first add items to the shopping list, remove items from the list. Next, we're going to view all the items in the list, and then we'll also write a code to exit the program. So let's go ahead and create our shopping list app. So for that, I'm going to go here and I'm going to comment everything from here because I don't want anything using the same variable names if I use it. And I'm going to go here and say, as usual, shopping list app. Now in this, our first step will be to initialize an empty shopping list. Initialize an empty shopping list. Now, how do I create an empty list? First, you give a name, shopping list equal to, and then just use the square brackets, which means it's empty. It's same as when we ran clear. Now we have an empty shopping list. Next step is to define the main menu for the user to check. So that's for user. So I say function show underscore menu. It's always good to write in function so you can reuse it and it looks much more modular. Here I'm going to say print /n dash 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 shopping list menu. Again, I'm going to use this bunch of times. So let's see if it's all good. I have add an item, remove an item, I have view shopping list, and we have quit. I'll call it exit. But before that, let me order them in a better way. I'm going to say one is view the shopping list, two is to add an item, three is to remove an item, and I will also add one more for four is clear list. And since I used 4 for that, I'll say 5 is exit. This is a proper menu now. Next step 3 is to the main program loop. Main program loop. Here, I'm going to say while true show menu. So this will run infinite number of times. And here, I'm going to say enter your choice from 1 to 5. So from based on what the menu is, because I've already displayed the menu to the user by running this, and then the user has this option. Here now, I'm going to first say if choice equal to 1, print shopping list. I want to display the shopping list because number 1 is view the shopping list. Shopping list for item in shopping list, print dash item. And I'm going to not use this anymore. I'm going to say that this is not what I want to use. I want to enumerate through the options. So first I'm going to check if not shopping list. I'm checking here, I'm saying not, I'm using not. If the shopping list doesn't exist, I'm going to say your shopping list is empty because initially it will be empty. So I'm going to show that. But else, I'm going to say for index, comma, item, enumerate shopping list, print index plus 1 dot item. So I'm going to show the list to the user. Next, I am going to write else if here because now what if the user picks 2 where user wants to add something, and I'm going to ask the user enter the item to add. What is the item that you want to add? And I am going to append that item to the shopping list here, and I'm going to say item has been added to the shopping list. So that's for item for option 2. I'm going to make sure there's enough space. Our next option is else if choice equal to 3. Now in case of 3, which is remove an item, I'm going to ask the user what item do they want to remove. So I'm going to say item equal to input, enter the item to remove. And then I'm going to check if item in shopping list. What if the item is not there? If it's there, I'm going to say shopping list, remove the item, and I say item has been removed from the shopping list. If it doesn't exist, I'll say item is not in the shopping list. What are you trying to remove? Something like that. So once that is over, next option is else if choice equal to 4. Now in case of 4, it is to clear the list. So it's very simple. I'm going to say shopping list dot clear. The shopping list has been cleared. I'll say that. Next option is else if 5. I'll say print exiting the program goodbye. So instead of this, I'm going to say goodbye and happy shopping, something like that, and break. And then finally, I'll say one more. Else, what if user picks something that is not between 1 to 5? I'm going to say invalid choice. Please choose or please try again here. So this is my entire code. I'm going to run through it one more time here. First, we are creating an empty shopping list. I'm going to create a menu here, and while true, I'm going to loop through this entire menu every time user selects something and goes through one of these steps. We have viewing the item shopping list. We have adding items, we are removing item, we're clearing the list, and we are saying exiting the entire while loop. This will exit the entire while loop because we are using break and close the program. So let's go ahead and run it. Here first, let's say one shopping list is empty, and it will go back to while loop again, and then again ask the question, add an item, and I'm going to say bread. Okay, it says bread has been added to the list. If I want to view it, I can say one, and as you can see, I have my shopping list displayed here with one, which is bread. I can add one more item. This time I'll say milk, add milk to it, and when I view the list, I'll see bread and milk added to my shopping list. If I want to remove an item, I'll specify 3, and then I'll say remove milk from my list. It says milk has been removed from the shopping list, and if I look at the shopping list now again, it will just show bread in my shopping list. Finally, we'll try 4, which is clearing the shopping list, and it says the shopping list has been cleared. So let's go ahead and look at the shopping list one more time, and as you can see, the shopping list is empty. Finally, let's go ahead and exit, and when I press 5, if you see, it says goodbye, happy shopping, and exit the program. So that's your entire application where you have created a shopping list and created basic functionality, which is adding an item, removing an item, clearing the list, and viewing the shopping list in this particular code. So just to break down the entire project, we did empty list initialization first, where we started with an empty list. Then we have a menu system where we display options using a while loop. Then we added item using append. We removed items using remove function. We looped through the list to display items, and we cleared the list using the clear function to empty the list. And we used the break to break out of the while loop. Now, bonus challenge for day 7 is to allow the user to edit an existing item in the list and then save the shopping list to a file when exiting the app. And then finally, add a feature to load the list from the file when starting. So try it out and let me know if you had any issues or if you have any questions in the messages, and I'll get back to you. Welcome to day 8 of your 100 days of Python challenge. Today, we'll dive into one of Python's most versatile data structures, which is dictionaries. By the end of this lesson, you'll have built an interactive contact book allowing users to add, view, edit, and delete contacts efficiently. Let's see what you learned today. First, what are dictionaries? Second, accessing and modifying dictionary values. Next, adding and removing entries, looping through a dictionary, and finally, our day 8 project, which is contact book. So first, let's look at what are dictionaries. A dictionary in Python is a collection of key value pairs where each key maps to a value. They are unordered, mutable, and incredibly useful for storing and retrieving data efficiently. Let's look at syntax. I've created a day 8 Python notebook, and here I am going to say my underscore dictionary equal to, and as I mentioned, they're key value pairs, so it will have something like key 1 will have a value 1, key 2 will have value 2, key 3 will have value 3. This is the syntax of how you create a dictionary. Now, example dictionary can be, let's say if I want to create a simple contact, I can say contact equal to, in this particular case, I will use name as John Doe. Next, I can say phone number of John Doe is 123 456 7890. Next, I can say email of John Doe is john at example.com. So this is a dictionary. Now, if I want to list the values from a particular dictionary or access a value of a key, the way you access is I can say print my name of my dictionary, contact, and inside square bracket, just like list, but instead of giving number, in this case, let's say I want to see phone. You can just say play here. What it does is it looks at the contact dictionary, looks for the key, which is phone, and will give me the value out. In this particular case, it will give me 1, 2, 3, 4, 5, 6, 7, 8, 9. The reason it's broken is because I forgot to close this. I'm going to run it again. And there you go, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. That's the phone. If I say name, run it again, this time it will give me John Doe. And similarly, for email, I can say email. Next, let's look at accessing and modifying dictionary values. Now, we already saw how to access values. As you saw here, I can just say print, contact, and name. Similarly, there's another way I can do that. I can just say contact, use a function called as get, and inside that, inside rounded brackets, I can say I want to get email. In this particular case, it does exactly same as what it does with contact email with square brackets. So either way is possible. It's up to your preference how you want to do it. Also, you can modify these values by saying, in this particular case, I can say contact, and I want to change John Doe's phone number. So I can just say phone equal to, in this particular case, I'll say 9807-123-456. That's his new number. Or let's make it more standard. There you go. So that's John Doe's new number. And when I save this and go back and try to print, let's say I want to print the entire contact and run it. It will tell me this is the email that got printed here, and this is the new contact. If you look at the phone number 980-123-4563, which is the new number which got replaced, and the old number got replaced with the new one. So that's how you can modify values inside a dictionary. Next, let's look at adding and removing entries. So we saw how to access them, how to modify them, but what if I want to add a new item here? So what I can do is, it's very simple. I can just say contact, and in this case, if you see address 123 Main Street, that's what I'm adding as a new key, and the value is this. And then I'm just printing the contact again just to see. And also, as I mentioned, if you want to remove something, you can just say del, which is short for delete, contact, and I want to delete his email. I don't want his email in this, and I'm going to print the contact. Run it, and as you can see, first it will print here with the new phone number. Next, I'm going to say address is 123 Main Street, and that's why you'll see here that an address is added with 123 Main Street. And then I'm going to say delete email, and if you see in the last, the contact when it's printed, it doesn't have any email inside it. So that's how you can delete email. So this is how you can add and remove entries into a dictionary. Next, let's look at looping through a dictionary. Now, looping through keys and different values is a little bit different from list, where I can say, for example, I already have the contact. Now I can say for key and value in contact dot items. So whatever data we have inside the dictionary are called items. So each one of them is one item. And I'm saying for key and value in contact dot items. So it knows that for each item, the key is, in this case, name, and then value is John Doe. Second, then it runs again for the second item. It says key is phone and value is this, or the new number that we have. And then it goes through address because we have deleted email. So it's going to go through the third item, which is address, and then print the value. Now, if I go ahead and I'm going to go ahead and comment this one, comment this one, and comment this one, so I don't have multiple lines. So this is the dictionary which is printed here. We have name, phone, and address. And then when I run the for loop, I see here name is John Doe, phone is this. I can make it prettier by using f strings. I can say f of, in here I can say key, and this is the value. Close it here. Now when I run it, I have a properly labeled name is John Doe, phone number is this, address is 123 Main Street, and that is what you can. I hope you got the exact same solution. If not, try it out. Also, you can check if a key exists inside a particular dictionary. So we have three keys here. I can check here if email, let me make sure it's properly aligned, in contact. I can say if email is one of the keys inside the contact, I can say email found, else no email found. Now if I run this here, it will print out saying email not found. But where did I delete it? Here, right? So I'm going to just go ahead and comment this out and run it again. This time it says email found. So you can check if a particular key exists by just using the key name if key in contact, and you can accordingly figure out if that key exists or not. So that brings us to our day 8 project, which is a contact book. In this project, the goal is to build an interactive contact book that allows users to add a new contact, view all the contacts, search for a contact by name, edit a contact's details, and delete a contact and exit the program. So as you can imagine, this is a good space to learn dictionaries. So I'm going to go ahead here and I'm going to go all the way to the bottom, create a new code snippet, forget about the one above, and here start writing our code for contact book. Again, as I always start with the name contact book. Next, I'm going to do steps. In steps, for step 1 will be initialize an empty contact book. So initially, let's say I just bought a new contact book from the store. So that's, I'm going to call it contacts equal to empty dictionary. So this is how you create an empty dictionary. Just like list, how you use the square bracket, for dictionaries you use the curly brackets. Next step, in this case, I will say display the menu. So something similar what we did in our yesterday's assignment or yesterday's project. We said show menu. This will be display a menu to the user to access the contact book. Here I'm going to say first print /n -- contact book menu, call it that. Next thing, I'll give all the options. I'm going to start with first option, which is add contact. I'm going to copy this over and be removed. Add contact, view contact, search contact, edit contact, delete contact, and exit. So these are my different options. I'm going to start with that. 2 is, as I said, view contacts, since I might have multiple contacts. Third option is to search for one contact, do that. Fourth is to edit a particular contact. Fifth is to delete a contact. And then our sixth option is exit the contact book. So these are our different options that we have. Next step is, I'll say step 3 is to write a function to add a contact. Also, I want to comment it out, so that's not used anywhere. And here I'm going to create a function again to add a contact. I'm going to say name equal to input enter contact name, phone equal to enter phone number or enter contact number, email equal to enter contact email, and then I'm going to say contacts of name, depending on the name that is key, is its values are phone is this and email is this email. So what I'm doing is I'm creating a key inside with values is another dictionary. So inside this, this will look something like, for example, once I add all this information from user, it will probably look like something like this. It will say name, whatever the name is. So for example, Vivian, the value is a dictionary which will have phone is whatever 1234, and then email is whatever @email.com, something like this. This is how it will be created. So my contact list will look something like that. So I'll go ahead, next line, I'm going to say print, and in this particular case I'll say name has been added to your contact book. So I can say contact name has been added to your contact book successfully. I like to make it more dramatic. Okay, perfect. So that's what I want to add. That is for add a contact. Our next function is to look at all the contacts. So I'm going to create another function for that. I'm going to say view underscore contacts. Inside this function, I will first check if contacts, that if there are contacts that exist, first I'm going to say contact list, and inside that for name and details in contact dot items, because if you know, this is the name that I'm saving, and then the second one, the value of that I'm saving is details, which is another dictionary. So details is my second dictionary. Inside that, so I'm going to say name is whatever the name is, the key. Phone is the detail, which is, this is the details dictionary. Inside that, I'm looking for phone. Same thing, inside details, I'm looking for email. So this is a dictionary inside a dictionary, pretty much, as you saw the example that I showed you. But this is a dictionary inside dictionary, and the main key is the name, and the value is a dictionary which has phone and email, and that's what we display here. Now, once I have displayed that, next I am going to say I'll get out else. So if that doesn't exist, if this contact doesn't exist, I'm going to say your contact book is empty. Or in this particular case, since there are, if contacts, I'm going to display everyone, or else I'll say your contact book is empty. Perfect. Next step is to search a particular contact. So I am going to say, I forgot to put my comment here. Step 4 this was, which was view all contacts. My step 5 is more on the line of search a contact. In this particular case, I'm going to say search contact function, and inside this function, first I'm going to say name equal to input, enter the name of the contact you want to search. So that's, oops, I think that's what I want. Yes, enter the name of the contact you want to search, and then I'll check if name in contacts, if name exists in the contacts, I'm going to say print contact details for name. So I'm saying for this particular person, the contact details are, this is the name, this is the phone number, and this is the email of that particular contact. Else, I'll say, oops, else I'll say contact name is not found in the contact book. Depending on what the contact was, I have not found that contact person. So that's what I'll display out. So our step 6 next is, let's go out here and I'll say step 6 is to edit a contact. So I'm going to say edit a contact. Something's mix of bunch of different things that we've done above. I'm going to say edit contact, and here first I'll say name, enter the name of the contact you want to edit. Name in contact is, I'm going to say editing contact, you want to edit their phone or edit their email. I can give options here based on what user wants to do, or another option is, let me just go back, and here I'm going to remove this. This is what the recommended one is from Gemini, but what I'm going to use is, I'm going to say for name in contact, phone equal to input, enter new phone number, email, enter new email. So I'm asking users new phone and new email, and then for my name, phone, email, is that what I'm going to save inside that contact, and I'm going to say has been updated successfully. So what I did was I asked for the name, and based on the name, I am just asking for the new phone and email, and I am saving that on top of the existing one. When you give contact's name, it will, and assign a value, it will automatically update that record in your dictionary. Next, okay, another one is else in here. Contact name not found. If the if loop doesn't work, then I will have to print that the name is not found in the contact book. Our next step, let's go ahead. Step 7 is to delete a contact. So in this particular case, I'm going to call delete contact, and again enter the name of the contact to delete, and then I'll check if name in contacts, I'm going to just say delete contact's name and just say print contact name has been deleted successfully. Else I will say print contact name not found in your contact book. So these are the different options. Now finally, our step 8 is to run the main program loop. Here I'm going to say while true, while this loop is true and we don't break out of it, first show menu and say input, choose your option, choose your choice between 1 to 6 based on the menu that we have displayed here. So this is what we're going to print and display your choice based from 1 to 6. Now, depending on the what user selects, I'm going to say if choice equal to 1, then I do add contact. Else if choice equal to 2, view contacts, choice equal to 3, search for contact, choice equal to 4, edit contact, choice 5, delete contact, we have one more choice, else if choice 6 equal to print, thank you for using the contact book, and I'll say goodbye, and then break out of the while loop here. Else, I'll say invalid choice, please select a valid option between 1 and 6. So that's what I'm going to display to the user. So now that I have this, I'm going to run this entire program. Let's hope there's no errors. There is an error. Else, I forgot to put a colon right here. Save it, run it again. And now there you go. Our contact book is ready. It says 1 is to add contact. I'm going to say name is Vivian Arana. Contact number 123 456 7890. Enter. Email is vivian at vivian.com. Next, it says Vivian Rana has been added to your contact book successfully. Next, I want to view all the contacts. Choose number 2, and then it shows me the contact list here. If I want to search a particular contact, I'm going to say 3, and then here enter the name, and I'm going to say I'm looking for Vivian Arana, and it's going to search and say this is the contact details for that particular person. 4, I want to edit, and then it says enter the name of the first contact you want to edit. So Vivian Arana, enter new phone number. I'm going to say 789 Enter. New email, I'll say Vivian at vivianarana.com. It says contact Vivian Arana has been updated successfully. And then I'll delete contact, but let's look at one more time if it saved properly. If you see the new number and the email has been added, I selected 2. Next, I want to delete it. So I'm going to say 5. And in this case, it is supposed to ask me for, yes, who you want to delete. I'm going to say Vivian Arana. And here I see that it's number 6 is contact. I think in the code, I have specified contact instead of exit. But anyways, I am going to go here and it says contact. Okay, it's gonna stop it, run it again one more time, and this time I'll say 6 just to check, and if you see it exited out, thank you for using contact book, goodbye, and it exited out the code. I can run it again, do all the things, but I hope you were able to follow along and get through this. Just to go through the project breakdown, we created a dictionary for storage which contains where contacts are stored as key value pairs, which was created right here. The menu system, we used a loop that allows users to navigate through options. We did CRUD operation, which is add, view, search, edit, and delete contacts. And we did dynamic updates where we saw the changes are reflected immediately in the dictionary. Now, bonus challenge for today is allow contacts to have multiple phone numbers or emails. Try that out. Next, you can save the contact book to a file and load it on startup. For the first option, which is multiple phone number and or emails, try to see how you can combine dictionaries and lists together. For this one, save the contact book. If you know how to save files, try that out. If not, we'll be learning about it in future videos. And finally, add error handling for invalid inputs. If you see, the only invalid input that we are looking for is the invalid choice, but nothing anywhere else. So you can try some error handling for invalid inputs. So let me know how it goes. If you have any issues or any problems, let me know in the messages and I'll get back to you. Welcome to day 9 of your 100 days of Python challenge. Today we'll explore two important Python data structures, tuples and sets. By the end of this lesson, you'll have built an ingredient checker that identifies missing or duplicate ingredients in a recipe. Now let's look at what you learned today. First, what are tuples? Tuple operations and unpacking. What are sets? Set operations like unions, intersection, and difference. and finally our day 9 project, which is ingredient checker. So let's jump into what are tuples. A tuple is an immutable data structure in Python. Once created, its contents cannot be changed, added, or removed. So tuples are useful for storing fixed collection of items. That's what you need to remember. Again, it's an immutable data structure, which means once it's created, its contents cannot be changed, added, or removed, and it's used for storing fixed collection of items. Let's look at the syntax of tuple. We created day 9 dot notebook, and inside here I am going to create my tuple equal to, and you use rounded brackets, 1, 2, and 3. So I've created a tuple with 3 elements in here, 1, 2, and 3. And this is how you create a tuple. As straightforward that. Lists were square brackets, dictionaries were curly brackets, and today we learned about tuples, which is rounded brackets. Now let's create an example. So I'm going to create fruits equal to, I have apple, banana, and cherry. I'm going to remove the rest of the lines here because I just need fruits equal to apple, banana, and cherry. And now if I want to access the first item, I can say print fruits of 0, just like a list item. So you can access them by index. Next, you can access the last element by saying print. If you say, let's say you have a tuple of 100 items, or you don't know how long it is, you can just say fruits of -1. This will give you the last item. If I run it, it will run through it. Again, 0 is 0, 1, and 2. But also the last item you can access by saying -1, and similarly you can say -2, -3, something like that. So if you see, you can access the first element, last element based on the indexes. Next, let's look at how you can unpack a particular tuple. So what do I mean by that? So a bunch of fruits here, or let's use a different example. I'm going to delete, or I'm going to comment this out, and then I'm going to create coordinates, which makes more sense. And my coordinates are 10, 20, 30. And now if I want to access these, let's say x and y coordinates, x, y, and z coordinates, I can just say coordinates. What it will do is it will assign the value of 10 to x, y will be 20, and z will be 30. And then since these are variables, you can always, of course, update these. I'm going to run this and you'll see 10, 20, 30. So x has the value 10, y has the value 20, and z has the value 30. Now you can't change a tuple, but these are variables and you can always change the values of variables. Next, let's look at tuple operations and unpacking. Now we already saw unpacking, but let's look at tuple operations. First, I'm going to look at basic tuple operations, where we have, let's say, our fruits element or fruits tuple, and I am going to comment this out. Now with this, I can look at how many elements there are inside this fruits. For that, I can just say print length, len, short for length, of fruits. So what this will do is this will give me the length of this particular tuple. I have 3 elements, and that's why it said length is 3. Next, I can also concatenate tuples. What do I mean by that? I can say print fruits plus, and create one more item, orange, and say comma at the end of it. What this does is, so I have 2 tuples here. I have a tuple with apple, banana, and cherry, which is this one, and I have a tuple with orange only inside it. The reason I put comma inside here, so it knows that it's a tuple with the item orange, and then I get the output apple, banana, cherry, and orange. So you can actually, you have multiple tuples, you can combine them into one tuple. Now why use tuples? Tuples are faster than lists. They're useful for data integrity, example coordinates, database records. They can be used as dictionary keys because they are immutable. So these are some of the reasons why we would use tuples over lists or dictionaries, or how we can use them in combination with lists and dictionaries. That brings us to our next topic, which is what are sets. A set is an unordered collection of unique items. Sets are mutable, but they do not allow duplicates. So think of sets is a list of items, but you cannot, I'm going to create a new, but you cannot add duplicate values inside there. So in a list, you can say 1, 2, 3, 1 2 3 1 2 3, but in list you'll just have to say 1 2 3. So for example, I can create my set, and again, sets are sets use curly brackets 1 2 and 3, just like dictionary, but doesn't have key values. It looks like a list but has curly brackets inside it. That's what a set is. So that's how you can differentiate between a set, a list, and a dictionary. So one of the example here can be, let's say if I want to create uh, a ingredients set, ingredients equal to, and my ingredients are, let's say I'm making cake or something. Let's say flour, sugar, and butter, and I can print the ingredients here, and if you see, this is how it will display you out. Next, let's talk about adding and removing elements. Now, you can add and remove elements here. I can say ingredients dot add. Very easy to remember. You can just say, let's say if I want to add x, I can say add x in this particular case. I can remove elements by saying ingredients dot remove. In this case, I'm removing sugar. And then I can print the ingredients and see how does it look like. Run it, and you'll see flour, butter, and sugar, and then became flour, butter, and eggs, because I've added eggs and I've removed sugar in this particular case. Next, let's look at set operations. So set operations, I'm going to talk about union, intersection, and difference. Now union is one which combines two different sets. Intersection is common items in two sets. Difference is items in one, not in the other. And is subset is check if subset of another set. So let's go ahead and create a new one, and this one I'll create set underscore a. So I have two sets in this particular case. I'll say in my first case I have flour, I have sugar, and I have butter. Next I have set underscore b, which has two values inside here. I have sugar and I have eggs. Now if you want to see the union of these two sets, you can just say print set underscore a and use the pipe symbol and say set underscore b. This will give you the union of two sets using the pipe. If you want to see intersection, you say set a and sign. This is the character which is above 7, or also called as and set b. This will give you intersection of the two sets. And then I'm going to remove this, set a minus set b. This will give you the difference in between two sets. If I run this, you'll see set a and set b, flour, sugar, eggs, flour, sugar, and butter and sugar, which is, if you look at all these four items, there is sugar repeated twice, but as I mentioned, sets do not have duplicates. So it has flour, sugar, butter, and eggs, which are flour, sugar, butter, and eggs. Again, the order doesn't matter here, but this is the union of the two sets. Next, intersection. Between the two sets, what is common? Sugar is common in both of them. That's why I see sugar. And this is different. Set A minus set B. So if I remove items that are in B from A, which is sugar, then I get flour and butter is what I get out here. So that brings us to our day 9 project, which is ingredient checker. The goal here is to build an ingredient checker that helps users identify missing ingredients from a recipe and extra ingredients not listed in the recipe. So what am I talking about? Let's look at the actual project. So I'm going to go ahead and implement it. Call it ingredients checker. In here, our step number 1 will be to define the recipe ingredients. So I'll say recipe underscore ingredients. So what are the ingredients that I need for my recipe to make a cake? I'll say flour, sugar, I'll just remove these, flour, sugar, butter, and I need eggs, and I need milk. I'm just making up. I'm not good at cooking, but I think I can just get the basic items right. Step 2 is get user input for available ingredients. So I'm asking the user what all ingredients that you have, enter them by comma separated. So I am going to say user underscore input equal to, I'm going to ask users input, enter the ingredients you have separated by, I'm going to use commas. And then I'm going to say user ingredients equal to, I'm going to create a set and say user input dot split. Since I said did not space but commas, I'm going to say give me the ingredients based on user's entry, and then if there's comma, just split them out. For example, if I enter flour, comma sugar, comma butter, it will split them and create a set and add it over there in this particular set called as available ingredients. And this is how you create a set, by the way, set, and it will add these items based on what I find inside a set. And if I repeat them again, like if I add sugar multiple times, it's just gonna make sure that it's unique and it will only take one set of sugar. Next, step 3 is to compare the ingredients. So now based on what user has, I'm going to check what are the missing ingredients. So I'm going to say missing underscore ingredients equal to, I'll say recipe ingredients minus available ingredients, which user has not, I've called it user ingredients, sorry, user ingredients. So recipe ingredients minus user ingredients. And what are the extra ingredients that we have? Extra ingredients equal to user ingredients minus the recipe ingredients. So that's how I can get the missing ingredients and what are the extra ingredients that we have. So based on that is my step number 4, which is display the results. So I'm going to do that. So what I'm going to do here is I'm going to first, as usual, print /n dash 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 ingredient check results dash dash dash. If missing ingredients, then print you're missing the following ingredients, which is join. I'm taking the missing ingredients, whatever I have here, which is recipe ingredients minus whatever user entered, and whatever I get, I'm going to join them using commas one after another and display them out to the user. So this is how you do it. You use curly brackets and then I say comma dot join. So join these values that are there in here based on commas. So if it's flour, sugar, so it will show up like this and display it nicely to the user. Or you can say you have no missing ingredients, you have all the ingredients that you need. So that's good. Next, I'm going to say if extra ingredients, you have these many extra ingredients, which I can say join extra ingredients, and these are the extra ingredients that you have. And if nothing is there, I say you have all the ingredients needed. I mean, you have nothing additional, you have everything that you need right over there. So now if I run it, and it's extra, enter the ingredients that you have. So I'm going to say I have flour, I have sugar, I have flour again. I'm going to enter again just for eggs. I have, I will say I have water, I have, let's say pepper, and I have salt. Enter. Now look through it and say you are missing the following ingredients: milk and butter. If you see, I don't have milk and butter, but those are the required ingredients here. Next, you have extra ingredients, which is pepper, water, and salt. So these are the extra ingredients which are not required for our recipe, and that's what it tells me. So this is how you can build an ingredient checker, and I hope you are able to follow along. The things that we did here was we did set comparison. We used difference to find missing and extra ingredients by using these negative minus subtraction sign. We did user input parsing. We converted user input into a set right here, and based on users entry, we separate them by comma and removed them from comma, and then created a set out of it. Again, if you see, I added flour twice, but it kind of ignored it and only took it once because it's a set. And we did got some dynamic feedback. We provided clear messages based on ingredient analysis and displayed these results out. So I hope you are able to follow along. Something that you can do as a bonus challenge for day 9 is allow the user to add alternative ingredients. Example, almond milk instead of milk. Suggest recipes based on available ingredients that user has. You can do that, and you can save and load the recipes from a file. Again, if you don't know how to do that, we're going to cover that in some videos in future. But again, try it out. Let me know how it goes. And if you have any questions or have any issues that you're facing while implementing this, let me know in the messages and I'll get back to you. Welcome to day 10 of your 100 days of Python challenge. Today, we'll dive into an essential Python skill, file handling. You'll learn how to read from, write to, and manage text files. By the end of this lesson, you'll have built a note taking app that saves, retrieves, and manages user notes in a text file. So let's see what you learned today. First, what is file handling? Reading from files. Then we're going to do writing to files, appending to files, and finally our day 10 project, which is note taking app. So let's go to what is file handling. File handling is a way to store, access, and manipulate data in files on your computer. Now, Python makes file handling easy with some built-in open functions. So let's look at a basic syntax. I'm going to open again in Google Colab, and in here, since it's on the cloud, the best way to access files is there's a folder on the left side, and here you can right click and say new file, and inside this I can just say file name .txt, something like that. So whatever name you want to give to the files, you can create that file here on the left hand side. Now, as per the syntax goes, let's see if I want to open a file. For that, as I mentioned, we have the open function available, which is built in. And here you give the file name. So whatever the name of the file is, let's say file name.txt, and then you specify what mode you want to read in. Now the different file modes available is read mode, where you can just say R. For write mode is W. For append mode, it's A. And for read and write, it's R plus, something like that. And then you can perform your file operations. And then when you're done with the file, you just have to make sure that the file is closed by calling file.close function. Now let's look at our next topic, which is reading from files. Now, first thing we're going to learn here is with statement, which ensures the file closes automatically. So we don't want to remember when to close the file, but once the functionality is over, I want it to close automatically. And to do that, what we can do is I'm going to close this. I'm going to rename this to something that makes more sense. For example, I'll say notes.txt file. And in here, I'm going to use the with statement. Now this makes sure that once you open it, use it with open function, it will make sure that whatever you open here, once it's no longer required, it will close the file automatically. So you don't have to specify. So let's say I want to read from this file as file. So with open notes.txtr as file. So this will kind of save this handle to the file in here as file. Now next, if I want to get the content from the file, I can create a content variable and I can say file dot read function. So what it will do is whatever content is inside the file, it will look at it and then assign it to here. So for example, if I say hello file notes, something like that, save that, and once that is saved, I can go back here. Okay, I didn't want to do this, so I can close this here, make sure this is deleted, and then I can just say print content. I'll keep this open just so that we can see it on the side, and then I'll run this file. So if you see here, hello file node. So depending on what I do here, files node, if you see the data value changes because this will read the file and use that open file as a handle here to file, and then I can say file.read, and whatever data is inside here will be read inside this content variable, and that's what is printed out. So file.read reads the entire content of the file, and again with statement ensures the file closes automatically after you're done with this file. Now next, let's look at writing to files. So I'm going to create another code snippet here, and I can say with, first I have to open the file again. So I say, let's say notes.txt, and instead of a I wanted to write, so I say w as file, and then I can say file.write, and I'm going to say /n, this is a new note, and then full stop, again /n, so it goes to next line, creates a new line, and that's what will be saved. So let's run this, and now if I open my notes file, you'll see this is a new note. return into this particular file slash n. So it created a new line, and if you see whatever was there in this particular file, it is overwritten. Now, if this file did not exist, let's say I call it notes1.txt, run it. What this W does is, if the file does not exist, it will create a file. So if you see here, we have notes1.txt, and it will create a new note inside whatever text I've asked it to write. It will write to that file. Now, existing content will be overwritten in this particular case. As you can see, whatever data I had here, my data, save it, and then change this to again notes, run it, and if once it's done, I can probably try to open again. Okay, there you go. This is the new note, and if you see, the old data was overwritten. So to be careful when you want to write. So reading R will read the file, write will overwrite anything. If the file doesn't exist, it will create a file and then write to that particular file. Now that brings us to, so we did writing to files, that brings us to appending to files. Now, if you don't want to delete the existing content and you want to add something to it, so for that, I'm going to create a new one. So with open notes.txt, this case, I want to append as file, and then here, I'm going to say file dot write, and I'm going to say this is a new second note, something like this, slash n. This will add the new content at the end of the file without overwriting. So if I run this now and open notes again, you'll see this is new node, and this is a new second node added to the end of the file. So wherever the file ends, it will add into the next line, because I say slash n, and add the data that I was specified, and created a new line again here, and that's why I have this another line here. I can do something without the lines to notes1, run it, open notes1, which is open here. If you see, it doesn't add a new line because I've removed the slash n at the end of it. So this is how you can append to write. So what we learned here was how to read from files, write to files, and appending files. That brings us to our day 10 project, which is a note-taking app. The goal here is to build an interactive note-taking app where users can first add new notes, view all the notes, delete all the notes, and exit the app. So let's go ahead and start with our code. I'm going to go ahead here and move all the way to the top, create a new code snippet, not the text one. I'm going to go ahead and delete this one. I'm going to close this right now. I don't need that. And here I'm going to say, first one, what is the name of my app? Note taking app. Okay, so that's my name of the app. And as usual, our step one is to define the file name. So I need to, it's always good to give a variable name for a file. I always try to put it all caps, so it's specific. And I'm not going to call it notes. I'm going to call it my notes.txt, because I already created notes, and so I want to create a new file completely. So that's the new file. Now, first step two is to display menu options to our user, which what we've been doing recently. Again, I'll say show underscore menu, and inside here I'm going to say, again, I don't like this style, I like my style, where I'm going to say note. First I'll specify what app is this app and what it is. In this case, it's a note taking app menu. Next, I'm going to say one, add a new note. That's good. And then second one is view all notes. I also want an option to delete notes. So I'm going to say third is delete. Let's delete all the notes. So I want to delete the entire notes. And fourth is exit. So this is number 4. Next, I'm going to have my step 3, which is, step 3, which is add a new note function. So I'm going to add the new note function here. For that, again, let's make sure that this is moved all the way to the top. Define the function. I am going to say add underscore note, and I'm going to ask the user, enter your note, and with open the name of the file. I want to append because I'm adding notes. There might be existing notes, maybe not, but that's why I want to append as file.write note /n. Perfect. And then I'm going to give a message to the user saying that note added successfully. Perfect. Next step. This time, step 4. This one will be to view all the nodes. View all nodes. Here, I'm going to define the function view nodes, and in here, I will use some error handling, which we'll be learning a little bit later. But I'm going to use try catch. What it does is it tries to run the following code. If it's successful, that's good. If there's some issues, which are also called as exceptions or errors, we can catch those errors here and close the application gracefully and give user proper message instead of just crashing the application. It might have happened sometimes when you're working with a particular application, it crashes all of a sudden without giving. We don't want to write that type of code. So what I'm doing is I'm saying try with open file name r as file notes equal to file dot, instead of read lines we say read file dot read. We're going to read everything in there, and in there I am going to say if so I am going to say this is content from the files, and I'm going to check if content exists. I'm going to say print all or your nodes in this particular case and display the content from that particular file. Else I'll say slash n in a new line, no nodes found. Next, if there was a file not found error, what will happen if there is no file error and we are trying to view the notes? For example, the notes, whatever my notes is, doesn't exist. And as soon as it opens, we say that, okay, display me the file, open the file to read. But there's nothing available right now. So it should give me no notes found, which is file not found error. It's a specific type of error. And we're going to look at these exceptions in more detail in future chapters. But for now, just trust me on this. It tries to open the file. If it fails anywhere because of file not found, it will give me this error and close the application gracefully. Next is my step 5, which is delete all the nodes. To do that, I am going to write function. Let's see how it helped me. Here, I'm going to write my own. So I'm going to first ask for confirmation. Confirm input. Are you sure you want to delete all nodes? So I'm asking the user, are you sure you want to delete y and n? I say yes. I usually make it more difficult because they have to capitalize y. N is easier. No, because they can just skip it. So I keep it small, but I keep y capital just so that they can. Sometimes I even say write the entire thing just so that I know that you're sure. And then I'm going to say if confirm dot lower, and then I'm going to convert this into lowercase and check if it's yes. Then with open file dot w as file dot write. So instead of doing this, so this will write empty text in there, which means it will replace everything with empty. Instead of that, another thing that you can do also is say pass. What this does is this overrides with an empty file. When you say pass, just pass, that's it. Next, I'm going to say print, and I'm going to give a message to user saying all nodes have been deleted. Perfect. Now there's else. If user had said no, I'm going to give a message saying that deletion cancelled. Anything other than yes, if the user specifies, I'm going to say deletion cancelled. What if they press escape or some other button? So I would have to want to catch that as no. Next, I'm going to say step 6. In this particular case, I have my main program loop where everything will start. So I'm going to say while true, first is show menu, choice equal to enter your choice 1 to 4 based on what was displayed in the menu, one of these options. And then I will check which option did user select. If choice equal to 1, then add the node, choice equal to 2, view the nodes. If choice equal to 3, delete nodes. Else, if choice equal to 4, then I'll say print exiting node taking app, goodbye. And then I'll break out of it. So break. And then finally, else, I'll say, make sure I have this, print invalid choice, please enter a number between 1 and 4. This is for the input loop. So let's go ahead, save this. I'm going to run it. In this case, I'm going to say view all nodes. Now the file doesn't exist. So if I say view all nodes, it says no nodes found because that file doesn't exist. It's just going to print this and it will not crash the application. If I say add a new note, I can say hello, my new note. Or let's write here something that we can understand, or actual note. Say learn Python. Okay, note added successfully. And if you see, it's trying to save that file. It'll probably save that in here. And there you go. We have the file here. And if I open it, it says learn Python here. Next, I want to add another note. Say learn AI. I'm going to say uh, give AI exam, something like that. So it says invalid choice here. Okay, because when I said give AI exam, I didn't say add a note. Okay, let me do that one, and then I'll say give AI exam. Okay, perfect. Now it's asking me what do you want to do. I want to view all the notes. Say two, and see my notes here. Learn Python, learn AI, give AI exam. Perfect. Can use the three now, which is delete. And I'm going to say if I did anything else, it will say deletion cancelled. So I'll have to be specific in this case and say yes, and all notes have been deleted. Perfect. Now if I view the notes, say 2, and in this case it says no notes found because there's nothing available in there. And then finally our option 4, which is to exit the code. So it says exiting note taking app, goodbye. And that's our entire application here. What we did was we learned how to add notes where we appended user input to a text file. Then we viewed the notes where we read and displayed the file's content. We deleted notes where we overwrote the entire file with an empty file by just calling this pass function. And then we did some error handling where we handled the file not found gracefully right over here, file not found error. So this is it for today, but something to play around with. Your bonus challenge for day 10 is add timestamps to each note. So try to learn how to add timestamps. If not, we're going to look at date and times in future. Next is allow users to edit specific notes by indexing them. So make sure that if you can index them, that's nicer. You can add an option to export notes as a separate file. See if you can do that. Just in case if you can't, don't worry about it. We'll be covering this in future. And if you have any questions or have any issues, let me know and I'll get back to you.